What's going on, everybody? In this video, we are going to be doing some SAT math review. I know you guys have been telling me to get this video out for a while now, so I did. Here it is. Let's hop right in. So this video is going to consist of 50 total SAT problems. I split this up into 30 and 20, 30 non-calculator problems and 20 calculator problems. You can see that I have the calculator problems in quotations because probably like half of them you'll need your calculator for, maybe even less, and that's generally how it is on the SAT anyway. It's kind of weird that way, but yeah, you won't need your calculator for all these problems. Also in this video, I have the timestamps in the description, and I also am going to pin them in a comment so you can go see that there. So if you're finishing up a problem, you want to move on to the next one before I get done with it in the video, you'll know where to go. And so that's all fine and dandy there. Now I'm also going to do an outfit change every 5 problems. I'll switch my polo off and we'll see how many polos I can go through in this video. I didn't know what else to do to keep you guys entertained during these 50 practice problems. So also I have an answer key in the description that you can go look at if you're just you're finished with the problem and you want to view the answer, but I haven't actually finished yet on the screen. There you go. I also have just a separate PDF with all of the practice problems without the answers. That'll also be in the description as well. Finally, I did want to mention the full SAT course, which I'm going to have listed in the description. And this course is just going to be a great chance for us to go through specific topics that you're struggling with. I'm going to have all the topics available that are in the SAT, and we're just going to go through all of them one by one. So yeah, if you're interested in that, check out the link in the description down below. But now, let's hop into this video. I can tell you guys are excited. So, first problem here says that the formula below is often used by project managers to compute E. This sounds like a really interesting problem. The estimated time to complete a job where O is the shortest completion time, P is the longest completion time, and M is the most likely completion time. And we're given the equation that E equals O plus 4M plus P all over 6. It says, which of the following correctly gives P in terms of E, O, and M? Okay, now I'm going to be honest here. I've seen a lot of problems that are like this, where they just give you a bunch of variables and they list off what all these different variables mean. And you don't care. Like you don't actually care what these variables represent. It's not going to help you solve this problem. So this entire first paragraph here, right? This entire thing, it doesn't matter, right? Because all it's asking for here is P in terms of E, O, and M. And so it wants you to solve this thing for P. That's it. And you can even see that with your answers, right? It's a good idea to look at your answers before you start working on the problem. And so you might get to this point and be like, okay, well, I know what the problem's asking now, but I don't know how to solve for P. And if you didn't know how to solve for P here, I would say, well, probably because you're staring at this giant fraction right here and you're getting a little, scared. So all you have to do in this case, right, when you start seeing a fraction in a problem, my best advice would be to just try to get rid of that fraction at all costs, or just try to simplify things. Now, we can actually get rid of that fraction here by just multiplying 6 on both sides, right? If we go through, and I'll just rewrite this over here, and we multiply that 6 on both sides, well, now those 6's are going to cancel out on the right side, right? And so you lose the fraction. And then on the left-hand side, you just end up with a 6e, right? And so 6e is going to equal O plus 4m plus p, right? And now just to solve for p, it looks like all we're going to have to do is subtract O and subtract 4m. Right? I know it's a little weird working with variables versus numbers, but really that's all this problem is asking for. So we're going to subtract that on both sides. And when we do that, hopefully you can see that I'm about to switch sides here. So I'm going to put P on this side, and I'm going to put this stuff on the other. We're going to have P is equal to 6e minus O minus 4m. Okay? And right there, that is choice A. All right? So, nice little easy first problem. And so now it's time to move on to the second one. Okay, so this problem is a little bit tricky because it's dealing with inequalities, and people tend to get freaked out when they see inequalities. But this problem says, which of the following consists of the y-coordinates of all the points that satisfy the system of inequalities above? So we look at our answers here, and we see that we have, y is greater than blank, right? So we can see, that y in this first equation, right? But you're probably like, okay, well, where does the second equation come in, right? Well, notice that both of these equations have x's in them, and there are no x's to be found here, right? So that probably means that the purpose of this second equation is going to be to eliminate x in this top equation, right? And then get us an answer that doesn't have any x's in it, right? And so, I know I could show you how to solve this problem in 10 seconds, but really understanding what's going on with these problems, right, that's going to help you a lot more, in my opinion, okay? So hopefully you can understand why I'm really going into depth on this. Awesome. So all you have to do, right, you see a 2x minus 1 here, you see a 2x here, right? It's like using substitution method to solve a system of linear equations, right? Like, having equations like this, and then having another one just like it, right? Like, say this, and then having to solve these two, and maybe use substitution method to solve it, right? It's like the same thing here. We're going to make this thing a 2x minus 1. How are we going to do that? Well, we're going to subtract 1 on both sides, right? And when we do that, we get 2x minus 1 is greater than 4, right? And we don't have to switch the sign here because we're not multiplying or dividing by a negative. So now we know that 2x minus 1 is greater than 4, right? And we got that from the second equation. Now we know that 2x minus 1 is less than y, right? And so we could just kind of tack that on the end here, couldn't we? Right? It's just saying, that's exactly the first equation. So if y is greater than 2x minus 1, well, then that means it's definitely going to be greater than 4, right? Because 2x minus 1 is bigger than 4. And so you could see that y is greater than 4. And that right there is choice B. All right? Awesome. So that's problem 2. Moving on to problem 3. Now we're going to throw in some geometry. All right? And this problem is, it looks really gross, right? It could freak a lot of people out just looking at it, but it's not that bad, okay? We'll see here. So we have that in the figure above, we're given all this information in the picture. We're also given that RT is equal to TU, right? So we have some lines of equal length here in this triangle, right? In this little inner triangle here. So it's asking us for what the value of x is right here, and that would be this angle over here. And so how would we get to that angle, right? Well, let's see, what did this RT equals TU do for us? Well, since we have these two sides that are congruent here, right, they're the same length, that means that this triangle is going to be isosceles, right? Why does that help us? Well, now we can find out what this angle is and this angle is, and maybe that's going to help us find this angle, right? And that is useful for us. So what I'm going to do is I'm just going to say, okay, well, let's call this angle, we'll call this angle y, okay? And we'll call this angle y, all right? And so I'll say y degrees, okay? Now these angles are going to, why I'm both naming them y, is because, well, they're the same, right? We just said that since we have an isosceles triangle, that means this angle is equal to this angle. So what we're going to do is say that 114 plus y is going to equal 180, because all the angles in this triangle are going to add up to be 180, right? And so that's going to be a great way for us to find what y is, okay? So we add these up, right? This is 2y. And then we can subtract 114 on both sides. Okay, we get that 2y is equal to, looks like this is going to be a 66, right? And then we just divide 2 on both sides. to get that y is 33. Okay, so y is going to be 33 here. So now we know these angles, okay? And so what else can we do, right? How can we use that information to find out what x is? Well, firstly, I'm going to show you the longer way, okay? And you're going to notice something about the longer way that will tell you what the shorter way could have been, okay? And so we'll do both here. Here's the longer way. What we could do now is see, okay, well, we have a 33-degree angle here, a 31-degree angle here, right, in this bigger triangle. And so we could use that exact same idea again to find this angle, right? The angle, I'll write it with a different color, this angle right here, right? Because these two angles, right, that yellow angle is going to be supplementary to the angle that we're trying to find. So we could just use, 180 minus and then find that other angle. So let's go do that. So it's going to be 2 steps, so it's going to take a little bit, but we're going to get it done. We know that 31 plus y, right, which is 33, plus this yellow angle, which I will call, let's call it w, plus w, is going to equal 180. Okay, well, 31 plus 33 is 64, plus w is 180. And then subtracting 64 on both sides, we're going to get that w is 116, right? 116, yes. Okay, so w is going to be 116. So now we know that, well, x is supplementary to w, right? So they have to add to be 180. So w plus x is going to equal 180. That means that x is equal to 180 minus w. And plugging that in, we would get that x is 64, right? And that is our answer, right? That's choice C. That's going to be the correct answer for this problem. But the problem here is that we've already seen 64 before in this problem, right? We've seen this, and so it was like 30 seconds before we actually solved the problem. So could we have known that that 64 from before was our answer? And that answer is yes. We could have known that. It's the fast way that I was talking about. It's actually called the exterior angle theorem. And so let me refresh your memory on what that is. So let's get rid of all this for a second. We could have realized that this thing was 64 using this theorem, which states that for this triangle right here, right, this external angle right here, okay, is actually going to be equal to the sum of the two opposite interior angles, okay? And that's what the theorem states. Why is that, though? Well, let's look at it this way. This 31, right, we know that 31 plus this y, right, plus that y is 33, right, plus w, right, the other angle in the triangle, we know that they're going to have to equal 180. We also know that x and w are supplementary, so x plus a w is equal to 180. Do you guys see here how x is then equal to 31 plus 33, right? X is equal to the sum of the other two angles. If you don't believe me still, why don't we just subtract these two, right? If we subtract these two, you get the w's go away, the 180s go away, the 31 plus 33 minus x is equal to 0, and that if you just add x on both sides, you get x is equal to 31 plus 33. Right? And, well, that right there is 64. Right? So knowing a little bit more about these theorems, right, the exterior angle theorem, that can help. So moving on to problem 4 now. This is a very common question that people get wrong. This is a square root equation, okay? An equation with a square root in it. And so let's just start solving this, right? It's asking for the solution set, meaning that we want to solve for x, okay? So let's start doing that. We have the square root of 2x plus 6 plus 4 equals x plus 3. Now, when you're solving a square root equation, you should start off by isolating the square root, right? Because to get rid of that square root, you're going to have to square both sides at some point, right? That's, the square root cancels out with the square, and so that's nice. How we can do that is by subtracting 4 on both sides. And when we do that, we get that the square root of 2x plus 6 is equal to, well, x minus 1. All right? Now we can actually square both sides to get rid of that square root. And when we do that, we end up getting that 2x plus 6 equals x squared. And it's really nice, guys, seriously, it's going to save you a lot of time if you don't have to expand this every time, right? If you don't have to write x minus 1 times x minus 1, and then expand it doing x squared minus x plus 1, and then writing x squared minus 2x plus 1, right? It's nice to know that x plus b, or actually rather, you usually see it as a plus b squared, is equal to a squared plus 2ab plus b squared. And if you know this, you can do this a lot faster, and it is going to save you some precious time on the SAT. So I would remember that. You can use that for this problem. And so we could have already seen that this is going to be x squared minus 2x plus 1, right? We can write it out as such, right? Awesome. So now we're going to just get all our terms to one side, right? We see that we have an x squared term, and so it looks like we're going to have to solve a quadratic. So subtracting 2x and subtracting 6 on both sides, oops, that's a little error, we get that 0 is equal to x squared minus 4x minus 5. All right? And now we just factor. What two numbers add to be -4 and multiply to be -5? I like to put that in a little x thingy. Well, that's going to be -5 and +1. So we can factor this into x minus 5 and x plus 1. Meaning that x is going to equal 5 and x is also going to equal -1. Okay? So that's it, right? That's our answer. It'd be -1 and 5 would be choice C, right? Well, no. No, you have to be careful when dealing with square root equations, right? Because you can end up with those extraneous solutions. Remember those, right? Yeah, that's this, right? That's this problem. You're going to end up with solutions that aren't really solutions. But let me talk to you about why, so you can, prepare for other problems that aren't necessarily square root equations. Here's the thing. It all had to do with us squaring both sides. That was the reason why we're getting solutions that aren't really solutions. Okay? When we square both sides, watch what happens. What we get right here would have been the exact same thing if I would have plopped a negative right here. Right? Because the negative goes away with the square, doesn't it? So what we actually end up solving for, the equation that these solutions are for, would actually be plus or minus square root of 2x minus 6 equal to x minus 1. That's what we've really solved for here. Okay? And so what we need to do is make sure that these solutions work for this original equation, because if they don't, well, then they're not going to be part of our solution set. Okay? We only want the positive solutions, right? Because we had a positive square root of 2x plus 6, not a negative. And you'll see later in this problem that actually one of the solutions end up being for that negative version of the equation. So watch this. Let's plug in that 5. And when we do that into this equation, right, we're going to get, and actually, this version of the equation is kind of annoying, so let's just use the version when I've already got rid of that 4. So we'll do a square root of 2x plus 6 equals x minus 1. We'll plug in 5 here, and in doing that, we're going to get the square root of 10 plus 6 equals 4. And you would agree, right? That's definitely the square root of 16 equals 4, right? 4 equals 4. So that one works. 5 works. But what about the other one? Well, let's try this again. Well, we plug in a -1. And look, I mean, you can already even see it's not going to work. Look over here. You're going to have a -2. And you can't have the, what comes out of a square root be negative. So this ends up being the square root of -2 plus 6 equals -2. You get the square root of 4 equals -2, and you get 2 equals -2. That's not right. But notice how this was a solution to the negative version of the equation. Watch what happens. We put a negative here, and then, yeah, they would have worked, right? So that's where the plus or minus, that's the whole idea, was from squaring. That's why we got this extra -1 in there. But now we know that that is not our solution. So all we have is that the answer is B, which is just 5. Okay? Awesome. Moving on to problem 5 here. Which of the following complex numbers is equal to 5 plus 12i minus a 9i squared minus 6i? All right, so this right here is going to be a little bit of combining like terms, right? When we see an I, don't freak out. You're just combining like terms. But if you see an I squared, well, you got to know what that actually is, right? That's not just, it's not like an x squared where you can just leave it as is. I squared is -1. We'll talk about why. But right here, right, this is 5 plus 12i minus a 9i squared minus 6i. The first thing I think anybody would do here is just distribute through that negative. I think it just is really helpful to do that, right? If you're not already doing this in your head at 1,000,000 miles per hour, which you can, right? Especially if you've gotten good at these types of problems, 100% go for it. But combining like terms here, right? We have a 12i, we have a 6i, we can make that 18i, and we can have a minus 9i squared here. But why did I say I squared was -1? And how would you even know that? Well, you're given that I is the square root of -1, right? So how could you use this to tell you what I squared is? Well, that's actually not that bad. You just square both sides. And just like we did in the last problem with the square roots, right? The square root here is going to cancel out with the square. And so I squared is actually going to equal -1. And so you can just tell that from the equation they give you in the problem for I. And so we substitute that in, we get a 5 plus 18i minus a 9 times -1, and that's just a plus 9. So our final answer here is going to be 14 plus 18i. And that right there is answer D. All right, now we are on to our 6th problem. We're done with our first 5, and so I did an outfit change. I don't know. I didn't know what else to do to like make this better. So, anyways, let's move on to this problem. In the xy plane, the graph of the equation above is a circle. Point P is on the circle and has coordinates 10, -5. If PQ is a diameter of a circle, what are the coordinates of point Q? Okay. So for this problem, right, we're given a circle. Okay? And we know that point P is just somewhere on the circle. Let's say it's up here. Okay? And its coordinates are 10, -5. All right, cool. Now we want to find point Q, right? We know that it makes a diameter with PQ, right? Or like when it's just connecting to Q. So Q would be on the opposite side of the circle, right? If this thing's going to be a diameter. And it would be passing through the center of the circle, right? And to find the coordinates of point Q, right, that's exactly what we're going to need to use here, is the center of the circle. right? That's exactly how I would go about solving this. Is, well, you have your center right here. You know what the coordinates are because you're given the equation of the circle. You're given that, well, your x would, the x center would be a positive 6. Your y center would be a negative 5. And so there you go. Yeah, you know, since you know that, you know, this thing's a line, right? You just keep following the line to get to Q, right? And so a little bit more about how you would do that, right? Let me just try to select this and move it out of the way because it's going to be in the way for what we're about to do here, right? All you have to do is be like, all right, well, to go from here to here, what do I have to do, right? Well, it looks like we're not even moving down at all, right? So I just, you know, I kind of placed this point randomly, remember? So, you know, if I actually had to place it again, it would have been over here, right? And we have to move left by 4. And so we'd have to do the exact same thing to get from the center to Q, right? We'd have to move down by 0, and we'd move over by negative 4. And so, well, you know, the y coordinate's not going to change at all. But we know that, well, the x coordinate's going to be 6 minus that 4. So we would get to negative 5. Right? That's just how a line works, right? You can make those steps. That's exactly what you do when, you know, you're talking about rise over run, right? Same thing. So that's your answer for question 6. On to question 7 here. This is a group of 202 people went on an overnight camping trip, taking 60 tents with them. Some of the tents held 2 people each, and the rest held 4 people each. Assuming all the tents were filled to capacity and every person got to sleep in a tent, exactly how many of the tents were 2-person tents? Okay, so there's a lot of information going on here. We should try to unpack it, right? We have, and that's kind of interesting because it's a tenting. It's a camping. I just said tenting. Okay, it's a camping thing. So I'm talking about unpacking. But haha, that was funny. Anyways, we have 202 people. We have 60 total tents. We have tents that have 2 people each, 4 people each, right? And we're asking how many of these tents were there. Okay, and so the thing that pops into my mind would be setting up a system of equations. And you won't really know it's a system yet, but looking at this, I mean, you know you're going to have to set up some kind of equations here, right? And so just starting to do that, we know that, you know, there's 60 total tents, right? So x plus y equals 60. We could at least say that, right? We could at least say that, you know, there's the amount of 2-person tents, x, plus the amount of 4-person tents, y, will equal 60, right? We can at least say that. We can also say that, well, 2 people in each 2-person tent plus the 4 people in each 4-person tent is going to equal the 202 total people. Okay, that's the other equation that you can set up. And the reason why I went to go set up that other equation is because we can't just solve and figure out what x is, what we're trying to find here. We can't just figure that out when we only have one equation, right? We have 2 unknowns. And so what we have to do right now, and I'm going to flip this so we can actually do a little bit of math here, we can just solve the system of equations, right? And so when you see a word problem, you're probably thinking set up some kind of equation. Doesn't have to be a system in every problem, right? But here, it looks like we can set up a really nice system and it's going to be quick to solve, okay? The reason why I say that is because we can just multiply this guy by 2 here, by 2 here, and then we can get the x's to cancel. So we get 2x plus 4y equals 202, and we get 2x plus 2y equals 120, okay? And you just subtract these 2 equations, right? So we get a 2x minus a 2x is going to be, well, that goes away. 4y minus a 2y is going to be 2y. And then we have 202 minus a 120, and, well, that's going to be 82. And so dividing by 2 on both sides, you can see that the amount of 4-person tenths we have is 41. Now we also, that's great that we know the amount of 4 people tenths, but we want to know the amount of 2 people tenths. And that is, we know that x plus y equals 60, so we know that there would have to be, 60 minus 41 2-person tenths, that's 19. Okay? So that right there is the answer for problem 7. Moving on to problem 8. Right, this equation, or this entire thing looks a little bit scary because automatically you see a fraction and you see an inequality, and so people are like, what? Right when they see this. But don't worry, it's not going to be that bad. I promise. It's actually just factoring. But we know what f of x and g of x are. It says, which of the following expressions is equivalent to f of x over g of x? And it says for x is greater than 3. That really doesn't seem to we don't really care about that right now. What you'll find later in this problem is that that's just like a domain restriction, which again, I'll get to what the heck that means, because you're probably like, what? So, we're given all these expressions that are f of x over g of x, right? We're trying to match them up. And so let's just, let's do it. Let's put f of x over g of x and see what we get. We get x cubed minus 9x all over x squared minus 2x minus 3. And to really simplify here, what are we thinking? Probably factoring, right? That would be the smart thing to do. So let's factor. We can factor out an x in the numerator and get a x times a x squared minus 9. And if you were, looking ahead trying to go fast with this problem, you might have been already able to see that you would get the x squared minus 9 and that you would get difference of perfect squares here. But let's say that you didn't get that right off the bat. We're going to put this over while we factor this guy. Right, the factors of this, it looks like x minus 3, x plus 1. Right, it looks like negative 3 and 1 are what? Add to be negative 2 and multiply to be negative 3. So we're going to break this up now. We have a x, and then we'll do difference of perfect squares here, right? We have x minus 3, x plus 3. And then this is over a x minus 3, x plus 1. Notice that the x minus 3's go away, right? They just cancel off. And so you're left with that f of x over g of x is equal to x plus 3, x times x plus 3, over ax plus 1. And that right there is choice D. Okay? So that was just a matter of simplifying. And also, by the way, the x greater than 3 thing, I was going to get back to that, right? The reason why we had to say x is greater than 3, why they had to say that for this problem, really ended up being because you're dealing with a denominator here, right? That denominator can't be 0. And if you let x pass over 3, right, this denominator would have went to 0, because you would have got a 0 here, and 0 times anything is 0, right? So that's why they said that. It doesn't really matter for us for actually solving this problem. We don't care. So problem 9, right, gives us a really gross looking thing, and it says that x is greater than 1, y is greater than 1, which this thing is equivalent to which of these guys, right? So looking at this thing, right, we're given a bunch of fraction exponents, we're given some negative exponents, and here it looks like we don't have any fractions or any negatives in our exponents, so we're gonna have to get rid of both of those things. Now, the first thing I always like to do is take care of negative exponents when dealing with something like this, right? With x to the negative 2, y to the 1/2, over x to the 1/3, y to the negative 1. I like to flip over the negative exponents, right? And if you see something with a negative exponent, right, you can picture this thing kind of like one of my followers told me it was like a dodgeball fight in a way. So where if people have, if the variables have negatives, for their exponents, that means that they're losing and they want to switch sides. So I actually really like that analogy. Yeah, it's basically like that, right? So this y to the negative 1, right, it has a negative in its exponent, so it's going to switch sides. And so the x to the negative 2 will do the same. So we end up getting y to the first power times y to the 1/2 power over x to the second power times x to the 1/3 power. Right? There you go. And now we can just take care of these fractional exponents. Now, what do you do with a fraction exponent? Well, a fraction in the exponent, right? We know that that exponent is power over root. I like to say p over r, right? Power over root. And so we know that, you know, that this 1/2, right? That just means we have a 2 as our root, and that's a square root. And then we have 1/3, right? That's a 3 as our root, and so that's a cube root. So we write this as y, right? That just this y is going to stay for now. Then we have the square root of y, right? That's the y to the 1/2. And then we'll do the exact same thing in the denominator, and that's an x squared times the cube root of x. And that right there is our answer, because you can see that it matches up with choice D. Awesome. So really, that's all you got to do when worrying about negative exponents. Problem 10. So this one can definitely trip a lot of people up. This, you know, you end up looking through this. You see the expression 1/3 x cubed minus, or x squared minus 2 can be rewritten as this thing, where k is a positive constant. What's the value of k, right? So you're looking for this guy. And, you know, the thing you should pick up on, right, is that you kind of see like a difference of perfect squares expansion here, right? You see kind of like a x squared minus 4 equals, oh, well, we know that that's x plus 2x minus 2, right? Where you see, you know, it's kind of like this, but just now you have k's, right? And so that's what is just automatically popping into my head here, and what I think should be, you know, popping into yours, because that's exactly what we're going to need to understand for us to be able to do this problem. So also notice that this 1/3 is already pulled out of this entire thing, right? It's not being just multiplied only by one of these terms, it's just completely out here. So I think a good first step would be to factor out that 1/3. Okay? Now that can be a little tricky, it can trip a lot of people up. What some people might do is say 1/3 times x squared minus 2/3, right? That's not the case. Okay, and if you're wondering how to pull a 1/3 out of a 2, right? Well, think about it. What happens if you were trying to pull a 3 out of a 2? Then you would get that 2/3, right? But if we're doing 1/3, it would just be the opposite. Instead of dividing 2 by 3, we're actually going to multiply by 3. Okay? And that's it. So 1/3 times x squared minus 6. Awesome. And now we have something. I know it doesn't look like difference of perfect squares, right? Because 6 isn't a perfect square. But our values of k aren't all perfect squares either, right? Like square root of 2, square root of 6, right? That's not going to be nice. And so what you get the whole x squared minus 4 thing that I brought up earlier, right? But what if we had something like, well, x squared minus 6, what happens then? And well, really, when you expand that, what you end up getting is 1/3 times x plus rad 6, x minus rad 6. Okay? That's the same thing as if you were doing it with, well, x plus 2, x minus 2, right? If you were doing it off of x squared minus 4, right? When you actually go and expand this, it's really x plus rad 4, x minus rad 4. Right? It just so happens that it's really nice to write these things. I mean, they're perfect squares, so it's just 2. But we can't make that same simplification here. And we don't need to, because we already have the answer to our problem. Okay? So hopefully you can see the similarity here and why I expanded it like that. Why I knew to. Because difference of perfect squares is really just this. Right? It just, again, the reason why we actually end up expanding like this is because, well, it can simplify really nice into this. Okay, that's the entire reason why we do that. So that's what this problem is really about. And so you can see here, right, it's x minus k, x plus k. That k here is the rad 6. So the answer to this problem is choice D. And actually, I'm going to circle that in orange. So another 5 problems down and another polo down as well. Now I'm on my 3rd polo. So anyways, we are moving on to problem 11 here. And in this one, it says, in the figure above, segment MQ and NR intersect at point P. Okay, cool, we got that. NP equals QP and MP equals PR. Okay, so we can mark that off right now, right? MP, that's this segment right here, is going to equal QP. All right, and MP equals PR. We can mark those off as well. What is the measure in degrees of angle QMR? And this is disregard the degree symbol when gridding your answer, right? So anyways, we need to find the angle QMR, right? That's this angle right here. Okay, and how do we do that? Well, you might think, okay, well, we know two angles of this triangle here, so we could just find the third one, right? And then maybe use that external angle theorem from before, because we know that this is an isosceles triangle. No, though, you can't use the external angle theorem here because this isn't like supplementary, right? Like this is not even complementary. You don't know what the angle measure is here, right? So don't even go thinking that at all. So it seems like it's not going to help us to find this angle out here. And you could do a quick check, right? You just, where else would I go if I have this angle here? There's not really much to do because you don't know what the angle measure is here in total. So the next thing you could think about is, okay, well, we see a straight line here. So we know that this angle, like we'll know that angle because it's supplementary to the 60, right? And so you could say that this angle right here, you call it W, right, is going to be 120, right? You can see that because it's going to be 180 minus 60 is going to equal W. And so W equals 120, right? And so now we know this angle measure. But how do we find this one, right? Well, again, we know this is isosceles because these two segments are congruent, right? So this is an isosceles triangle right here. Okay? And so these two angles are the exact same. Let's call them, we'll call them S. Actually, no, I'm going to call them X because S is weird. Okay? Let's do that. So we know that, 120 plus both of those angles, right, 2x is going to equal the full 180 in that triangle. And just solving for x here, subtract 120 on both sides, right? 2x is going to equal 60. Divide by 2. We get that x is 30. Okay, sorry if I go a little fast on that algebra there. That's really what this problem amounts to, right? We start off trying to figure out which angle we can get that's going to actually help us so we're not doing a bunch of unnecessary work, okay? And really, you're doing that thinking a lot faster than we're just talking about it here in this video, right? You're just making that quick check. Okay, this isn't going to give us anything. Moving on to, oh yeah, supplementary angles here. Go with that, right? That's kind of how that process should be for you, okay? And that's basically this problem, okay? Mostly strategy, really. Problem 12. Now we have a curve. And it says, which of the following could be the equation of the graph above? Okay, this is all about zeros, right? This is giving us where this graph intersects the x-axis. And the reason why I know it's about zeros is because, well, the way that these equations are all like kind of sprawled out here, that's all the zeros here, right? And so we could just match the zeros in our answers with the zeros here. So where do we know that there is zeros? We know that there is a 0 at -3, at 0, and at 2. So you would think that, okay, well then y would be, you switch the signs, it'd be x plus 3, x, right? That's what x would be for 0, right? And then you'd have x minus 2. And that right there is choice A, right? So that would be your answer? No, it wouldn't. Because you need to worry about this thing called multiplicity, right? Which is, does this x have a square on it? Does anything else have a square on it, or all that, right? And so what would tell you that, right? Well, it depends if this graph goes through the x-axis or if it just touches the x-axis. There will be a difference there. So If the graph goes through the x-axis, that means it has a odd exponent on it, so 1, 3, 5, 7, whatever. Those will all go through, right? So if this said cube, right, I mean, it would still go through. But now we have something that just touches the x-axis, and that means that it has an even multiplicity. That means that there's either a 2, a 4, a 6, an 8, or whatever here on the x, right? Because that's what we're talking about, right? That's the x. And so here, I mean, our answer, right, it says which of the following. So it's not saying that there's one definite answer for this, right? It's just saying, okay, well, you know, which could be the equation, right? It's not saying that it definitely is, because, you know, then we'd have to think about, okay, well, is it a fourth? Is it a sixth? Is it an eighth? Whatever, right? We know it's got to be an even exponent, and so we put an x squared there. X minus 2 goes through, and so it's fine where it's at, right? It's got an odd multiplicity, it's got an odd power, right? Same thing. And so we're fine. So our actual answer is going to be x squared x. We could write it as x minus 2 to kind of work with our answer here. And x plus 3. And that right there is choice B. Okay. So it all depends on if at year 0 the curve goes through the x-axis or it just touches it. That's it. Okay, and that's going to determine what happens to your equation. Problem 13. We have a really weird word problem here, right? We have some, like it says million in places, like that might just start freaking people out and be like, ugh, like eye rolling and everything, right? Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreased at a constant rate, always underline if you see the word constant rate, right? What does constant rate mean? It means a line, okay? It means a line. That's what that is, okay? That means like you have a constant slope, so you're doing constant rise over run. So it says, assuming that the oil and gas production decreased at a constant rate, which of the following linear functions, and there you see line, right? The word line. And that would work with, you know, constant rate. Which of the following linear functions f best models the production in millions of barrels t years after the year 2000? Okay, so a couple things to note here, right? I mean, we're trying to find an equation to represent this decline, right? But it's exactly that. It's a decline, right? We're going from 4 million barrels to 1.9 million barrels, right? And that means that we're going to have a negative slope here. Right, this line's going to be going down. It's decreasing at a constant rate. And so we know that we're not going to have a positive slope. So A and B aren't going to be it. And then it's really just a matter of C or D. Right? And so it seems that we're going to have to figure out our slope here. So let's do that, right? Our slope would be y2 minus y1 over x2 minus x1. Right? So we could pick our final destination, you know, that's the x2, y2 point, right? That's the final amount of barrels that we get, and that's 1.9 million. So we can just write that as 1.9, right? And, you know, you just know that your slope is going to be kind of like in the millions, right? So we know that that corresponds to 2013. We subtract. We know that we had 4 million barrels into the year 2000. And so we just go and subtract here. Here we're going to get, in the numerator, we get a negative 2.1. In the denominator, we're going to get a 13. And so you see we have a negative 2.1 over 13. That doesn't seem to match what we have here, does it? I mean, here we have 130 in the denominator. And well, that's the reason why they did that is because we don't want to have a decimal in our fraction. That's gross, right? So we can actually multiply this thing. Right, we'll take negative 2.1 over 13 and multiply it by 10 over 10. And that gets rid of the decimal place, right? It moves these things up a decimal place. And so that's how you get the negative 21 over 130. Right? Multiplying this thing by 10 over 10 doesn't change the value at all. Okay, I mean, that's 1, right? 10 divided by 10 is 1. But it just helps you write this in a more clean way. And so you see here that choice C is going to be your correct answer here. And I'll circle that in the color of the section. All right, 3 problems down, 2 to go before we're done with our next 5. The next problem is a breather. Okay, this is a really nice problem. Okay, we get that 2a over b is 1/2, and it asks what's the value of b over a. So for this problem, right, we're given an a over b. We want to find a b over a. I feel like this is a really, really common problem on the SAT, right? All we have to do, I mean, we're going to have to flip this, right? Because we want to reverse the order of these because we need a b over a instead of an a over b. So we can take the reciprocal on both sides, right? And that, to do that, we just write a -1 in the power, right? That's what that means is we end up flipping both sides. That's how you write that mathematically. This becomes a b over 2a equal to 2, right? And then you just, to get b over a, right, you need to get rid of this 2. How do you get rid of that 2? Well, you could multiply by 2 on both sides, right? And you get b over a is equal to 4. I know, I think a lot of people can get tripped up knowing that they have to multiply by 2 here. It's kind of the same thing. Like, what if you had 2b over a equals 2, right? Would you know to divide by 2? Right? That's what you would have to do on both sides, is you'd have to divide by 2, right, to get rid of the 2's. It's the same thing here, right? Instead of dividing by 2, you have a 2 in the denominator, so you multiply by 2 to cancel out. In the end, you get the b over a is 4, and that's choice D. Last problem of this set of 5. Problem 15 says, it gives us 2 equations, and it says how many solutions are there to the system of equations above. Now, here's what I like to think about when I'm looking at an example like this. Okay, I like to think about what are the actual, like, the equations of what? Are they a line? Is it a parabola? Is it a circle? What am I actually looking for intersections with, right? Well, we know that this thing is an x squared in it, right? It's got an x squared, got an x, and it's got a constant. It's a quadratic, right? It's a parabola. This guy right here, I mean, it's got y's to the first powers, x's to the first powers. This is going to be a line, right? You're going to be able to write this in y equals mx plus b form. You can do that in your head if you want, okay? So that right there tells us that, well, there's no way there could be 4 solutions to this problem, right? If you have a line intersecting a parabola, right, which is really what that means when you say how many solutions to the system of equations, right? You're asking for where do these 2 things intersect? That's the solutions, okay? They can either intersect in 2 places. It can intersect in 1 place if you have just a straight line hitting the vertex, or just, like a singular point on the parabola, or it could just be off in space somewhere and not hit it at all. So 2, 1, and 0 are our possible cases here, okay? And not that knowledge really helps you that much for this problem, but it might help you for other problems, and that's why I've been really slow with my explanations in this video. I just really want to, give you as much information as I can, and that maybe some of this you were missing, and you can apply it to other problems. So, yeah. So here, what I would do, right, if we're trying to find solutions, I would just solve for y for both of these and then set them equal to each other. We have what y is here. We could find what y is here by, actually converting this thing to y equals mx plus b form. To do that, all we would have to do is, add 5x and subtract 8 on both sides. And in doing that, we would get y equals 5x minus 8. And now that we have this thing, we also have the parabola. We can set them equal to each other. We get that x squared plus 3x minus 7 is equal to a 5x minus 8. Subtracting 5x and adding 8 on both sides to, just get everything to one side here, we're going to get x squared minus a 2x plus 1 equals 0. Now, from here, there's a couple things that you can do, okay? You're looking for a number of solutions here, okay? So you don't really, I mean, if you see an obvious way to factor it right off the bat, then go for it. But quite often, you're gonna not be able to find a way to do that, right? It's gonna be, like there'll be zero solutions, and so you'd actually end up getting a negative under the square root in the quadratic formula, right? And so you'd have to first off fail at factoring and then move to quadratic formula. When you're trying to do problems like these, I would try to opt to quadratic formula right away. Okay? And don't even do quadratic formula, just do the discriminant part, do the square root part, and that'll tell you automatically. So there's two ways that you can go about this. You can use the discriminant, or you can also realize that this is just x minus 1 squared. Okay? You can realize that, and then you just see that there's x, this is x equals 1, right? And that's one solution, right? Just square root both sides. And you get that x minus 1 equals 0. So x equals 1, right? You can do that. And that's the short way, but a lot of you won't recognize that, okay? And I'm not trying to be mean. I mean, I'm just trying to deal with your guys' nerves on the test, right? You can use the discriminant, which is the square root of b squared minus 4ac. Because this is what determines how many solutions there's going to be. If this thing is 0, there's going to be one solution. There's just going to be one solution, right? If this thing is negative in the square root, right? If it's imaginary, then there's going to be no solutions. And if this thing just yields some random number that's not 0 and not imaginary, there's going to be two solutions. So plugging in here, we know that b squared is going to be negative 2 squared, right? That's 4. Then we have minus 4, a and c are both 1. So we get square root of 4 minus 4. And that right there is 0. So we actually get one solution, and as we just saw down there. So one solution. Okay, and just so you can actually see why that is, real quick. If you actually plug this thing into the quadratic formula, you get 2 plus or minus, that discriminant is 0, right? And then you'd have over 2a, that's 2. So you'd only get 1 here, right? The plus or minus, that's what gives you the two solutions. And since it's just 0, it goes away, and that's why you only have 1. Okay? So hopefully that helped. Awesome. So that's choice C. All right? And yeah. I'm going to go eat dinner, and I'll be back with a new polo. Bam, and we're back with another polo, and it's time to do our next set of 5. All right, and guys, honestly, I do recommend taking a break after, like each 5 problems, maybe each 10 problems. I think it would be really beneficial to you so you don't burn out with this entire video, right? So problem 16 here, looks like we got a big old circle here, and we're trying to find this angle right here, right? Because it says in a circle above, point A is that center of the circle, right? And the length of arc BC, right? That means this guy right here is 2/5 of the total circumference of the circle. So then it asks us for the value of x, right? And the trick for this problem is that you need to know that the amount of arc that has been, or the size of the arc that has been traced out is proportional to the angle, meaning that they're going to have like the same ratio, is what I mean to say. Okay, and so this 2/5, right, of the entire circumference of the circle, that's actually going to be equal to, you can kind of like set up two fractions here, right, and then do some cross multiplying. This is actually going to be something out of the total angle, the total degrees in a circle. Okay, because the ratios are the same. Okay, that's just something you got to know about circles. Okay, the arc length is going to be proportional to the angle measure. Okay, so this is going to be, well, I mean, this is the angle that we're trying to find, right? This is angle x. This is the angle of the arc that has been traced out. So that's x. Okay, and then we just cross multiply, we get 360 times 2. equals 5x, right? This ends up being 720 equaling 5x, and dividing by 5 on both sides. You can just do some like long division there, because I don't believe this is a calculator problem, because those are all after problem 30. But yeah, you get x is equal to 144 degrees. Okay? And that's your answer for problem 16. Okay, so again, just make sure that you know that the arc length that you trace out is proportional to the angle, right? They're going to increase at the same rate, right? So if you've traced out 3/5 of the circle, well, now you can also, again, go find the angle, okay? Problem 17. This one's surprisingly easy. You would think it would, it's like some word problem, it's going to be really nasty, but actually, this one will be nice. I should stop spoiling the problems. Okay, I'm gonna stop. A startup company opened with 8 employees. The company's growth plan assumes that 2 new employees will be hired each quarter, every 3 months, for the first 5 years. If an equation is written in the form y equals ax plus b to represent the number of employees, y employed by the company x quarters after the company opened, what is the value of b? Right? Well, b is the y-intercept, right? We know that. But what you need to know about the y-intercept always, right? The y-intercept is the initial amount that you're dealing with, right? We're talking about x quarters, right? And so 0 quarters is the y-intercept, right? That's the x-axis or the y-axis, right? So what I mean is this. You have your y, you have your x, and you have some line. Okay, and actually I'll draw this up here. Okay, your initial amount of employees is going to be what you're at 0 quarters, right? When you have 0 quarters, and that's 0 on the x. So that means you haven't gone this way at all. So yeah, it's going to be your initial point. And so the amount of employees that you start with is 8, right? And that's your y-intercept. So b is going to equal 8, right? This equation will be y equals ax, whatever a is, then you have plus 8. Okay, and that's all we really care about for this problem. So, wha-bam. Problem 18. I didn't type this one up. Okay, so which of the following is equivalent to 4x squared plus 6x all over 4x plus 2? And here we're given a range of options here. Okay, and here's the thing. You see answers like C and D, right? And it looks like this thing would have had to be long divided just so you could get those 2 answers, right? With long division, you have, some terms, and then you have a fraction at the end, right? That's how you know something's been you're dealing with like a quotient, right? You're dealing with a, quotient plus remainder over divisor, right? That's the form of long division. And we're going to do that in a second here because it's going to be smart to long divide this, okay? So let's go ahead and do that. I wouldn't really simplify this here, by the way. I wouldn't like take out a 2 of top and bottom. I was tempted to do that when I first looked at this problem, but then I looked at the answer here and you have 2 over 4x plus 2, right? You could have taken out a 2 out of this answer as well. So I don't think that simplifying here is going to help you because the answer isn't simplified to begin with, right? Or any of these answers, right? Any of these fractions, 2 over 4x plus 2, right? So let's do some long division here. We're going to do that 4x plus 2 divided by 4x squared plus 6x. Okay, and then how many times does 4x go into 4x squared? Well, that would be x times, right? Because you have to multiply 4x by x to get 4x squared. So then multiply x by 4x and you get 4x squared. Multiply the 2 by the x and you get 2x. And then you're going to subtract this thing. So 4x squared minus 4x squared is 0. 6x minus 2x is 4x. Okay, and then you go again. How many times does 4x go into 4x? Well, that'd be 1. So you get plus 1. Okay, and already you can see the answer is choice D, right? Because you get that plus 1 there. But we can keep going here because I do want to show you the full form here. And so, yeah, 1 times 4x is going to be 4x. 1 times the 2 here is going to be plus 2. And then you subtract this entire thing. So the 4x's are going to go away. You get 0. And then you get a minus 2 on the end, right? Because you have that minus out front. So your quotient here is x plus 1, right? And so the answer is x plus 1, but then you have to do remainder over divisor, right? Your remainder is negative 2. So you can do, you do minus and then that 2 up there. Your divisor is what you're dividing by, right? So how would you know what you're dividing by? Are you dividing by this or this, right? Well, it's 4x squared plus 6x divided by 4x plus 2. And so it'll already, it'll tell you just by, saying out what the problem actually is. And when you do that, right, you write it out into Q plus R over D form, right? Quotient plus remainder over divisor, you get choice D. Awesome. So moving on to problem 19 here, we're trying to find the volume of a right circular cylinder, or no, actually, let me rephrase. The volume of right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? Now, make sure you know that for these volume problems, right, you're going to have to deal with some on the SAT. They give you the volume formulas at the beginning of the SAT, right? A lot of newbies to the SAT, they'll forget about that, right? I can't tell you how many times I've been in college and I forgot that in the beginning of the test, there's a formula sheet that I can use, and then I'll get problems wrong and I'll be like, ugh, right? And it'll be annoying. So make sure you're using that formula sheet, and so you would know that the volume of a right circular cylinder is pi r squared h. How I like to think about this is that the area of a circle is pi r squared, and then when you extend this up by h, right, it's kind of like it's the same thing, right, that the h just gets multiplied on, just like a rectangular prism would, right? For instance, the area of a rectangle is going to be length times width, and then you extend it to form a rectangular prism. That's an awful okay, bad drawing. But you extend it by some h, right? And then your volume is length times width times height, right? And so you have to just multiply by that height at the end. It's the same thing here. The area of your circle is pi r squared, and then you multiply by the h. So either that 30 seconds was just a, stupid rant that didn't make any sense to you, or it was actually helpful. I don't know. Anyways. So that's how I think about it. Their volume is pi r squared h here, and we know that this volume is 22, right? So we know that 22 is equal to pi r squared h. But we're saying, well, what's going to happen if we double our radius? Okay, so we'll do that first. Okay, so something's equal to, we're going to have 2r now, right? We're doubling that radius. Right? And remember, what is in here is the new radius, right? And that gets squared. It's not going to be 2r squared here. It's going to be this entire, because this is the radius, right? The radius is what gets squared. The radius here is 2r, right? It's 2 times the original radius, okay? And then we're also going to half the height here, so we're going to multiply by 1/2 h, okay? So going through here, we're going to get a pi times, looks like a 4r squared times 1/2 h. And then just simplifying this, it's going to be a 2 pi r squared h, right? And we know that pi r squared h is 22, right? That's what this says. That was our original volume. So our final volume, well, that's going to be 44. Okay, you're just doubling the volume. That's what this 2 does. Okay? Because if you double the radius, it quadruples the volume. And if you half the height, well, that's just going to half the entire volume. Okay, so it's different, right? It's not going to be the same effect as it would. It's not the same effect for radius as it is for height because the radius is being squared. Anyways, your answer here is going to be choice C. Moving on to our last problem for this set of 5, we have a exponential function problem. Now, this problem says that f of x is 2x plus 1. And then it's saying, okay, well, we're going to negate this whole thing. And so what's the new graph going to look like? So to understand what the new graph is going to look like, right, we need to know what this graph looked like to begin with. And that's just going to be a regular exponential graph, right? It's going to look like, like this. The only thing is we need to figure out where that y-intercept was. And how do you figure out where the y-intercept is in something that's, not a line? Well, you can plug in 0 for x because, well, at x equals 0, right, that's the y-axis. So plug that in, see what you get for your y value. Plug in 0 here, and we get y is equal to 2 to the 0 power plus 1, right? And we get from here a 1, and from here we get a 1. So that's just 2. And so this y-intercept is 2. So now what we're doing is we are putting a negative out front. And what you need to know is that if you are negating an entire function, okay, if you negate an entire function, you're going to end up here with y equal to negative this entire thing, right, the 2x plus 1. What this negative does if it's being multiplied to this entire thing is it's going to flip it about the x-axis, right, meaning it's going to flip it over this way. Okay, that's what it will do. And so imagine this, actually I'll do that. Imagine this thing getting just flipped about the x-axis. It will now look like this, right? And it will have a y-intercept of negative 2. Okay, and so I'll make that, I think the section is green, right? If I'm right. Yes. Right? That's going to be our new graph. All you have to know is that just the negative will flip it about the x-axis. And so that's going to be choice C. Okay? Awesome. So that is it for another set of 5. Now we're going to move on to problems 21 through 25. And of course, this wouldn't be complete without a new polo. God knows why I'm still doing this. All right, so problem 21. This is a little bit tricky, okay? Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5, assuming gasoline costs $4 per gallon. Which equation can Alan use to determine how many fewer average miles M he should drive each week? Okay, so I say this is a little bit tricky because just setting different things up, this seems like a unit conversion problem, right? You're given a lot of different pieces of information like miles per gallon or, dollars per gallon, all that stuff, right? And so you got to figure out how to kind of assimilate that stuff in the right way, right? To kind of construct something that'll actually work. Okay? So we're given a bunch of different things, right? It's good to start writing down what we're given, right? We're given 100 miles per week. We're given 25 miles per gallon. Right? And I think it'd be best to, since it looks like we're doing a lot of unit conversion here because we're given a lot of different things with a lot of different units, right? I would say that we should just write it like that. Okay, we're also given that he wants to reduce his weekly expenditure by $5, right? So we want to reduce by $5. We can write that down. Assuming gasoline costs $4 per gallon, we could write that down as just dollars per gallon, just so we can see all the units. And we're trying to see, well, how many fewer average miles should he drive each week? Okay? So we want to have some miles, some, M miles. We want to drive some M miles fewer to where we are saving $5. That's what we can already tell right from this problem, right? We want something with M miles to save us a total of $5, right? And that right there already cancels out A and C, right? Because they equal 95 for some reason, okay? So the problem that we're having now is going to be finding this stuff out here, right? What's actually going to be out here? And we have two choices. We have 25 over 4 or we have 4 over 25. And actually, to be honest, I wouldn't even just go about thinking about this. I would just plug in to what you see here and see if it works, right? You see that you have, right, you have dollars over here, so miles has to cancel out. And so you want to put that miles per gallon in the denominator, right? Because miles, if it was in the numerator, you'd get miles squared, and that wouldn't make any sense. So you can also, I guess what I just did was actually think about it. So I guess I'm going against what I just said, but hopefully you get the point, right? We're going to cancel out miles here, right? And if we include the $4 per gallon on top, because you can see here we're going to get 4 over 25, right? We can do $4 per gallon. The gallon in the denominator here will cancel out with the gallon in the denominator of the denominator, and we're left with just dollars, right? So we get that 4m over 25 is equal to 5, and that right there is choice D. Okay, so a little bit tricky, but again, it's really all just unit conversion. Okay, so moving on to problem 22. Problem 22 gives us this little guy here. And it says the expression above is equivalent to a over x plus 2 squared, where a is a positive constant and x is not equal to negative 2. What's the value of a? So we need to get this giant thing into this thing, right? And how do we do that? Well, we have two fractions. How do we combine that into one fraction? Like literally any time ever. We find common denominators and we just combine, right? It's just adding two fractions. This example is actually, and this is subtraction here, but this example is literally subtracting two fractions just with a lot of x's involved, right? So this is like the hardest example of subtracting two fractions. No, but seriously, that's all this is. To get common denominators, we just need to multiply this x plus 2 by another one of itself. So we get the x plus 2 squared, right? If we multiply 2 over x plus 2 by a x plus 2 over x plus 2, we're going to get a 2x. See if you can follow me here, right? That 2x gets distributed, or the 2 gets distributed to the x, the 2 gets distributed to the 2, and we get 2x plus 4. Okay, and then this is going to be over the x plus 2 squared, right? That's what x plus 2 times itself is going to be. So we are going to get 2x plus 6 over x plus 2 squared minus, remember what this new thing is, right? It's this thing. It's going to be 2x plus 4 over x plus 2 squared. Okay, and then you just got to figure out what this denominator becomes. Okay, and you can already tell if you're doing this right or wrong because a, right, is just some positive constant. I mean it's going to be like a 7 or a 9 or a 2, right, or something like that. Okay, it's not going to have any x's in it because it's a constant. A constant means it doesn't have that x in it. Okay, so we should see our x's here cancel out in the numerator, and they will. So think about this, right? If the subtraction sign's here, you still need to distribute it, right? So we're going to get a 2x minus a 2x, and that's 0. Then we get a 6 minus a 4, and that's 2. And so here we get that the a is 2. Okay, and that is our answer for problem 22. Awesome. Problem 23. Intersecting lines R, S, and T are shown below. What's the value of X? Okay, so to get to this angle, right, given these guys, what are we going to do? Well, we don't have either of these angles, right? We don't have them yet, so we can't just add all the, we don't have two of them at least. If we had two of them, then we could add all of the angles up and get 180 and then figure out what the other angle was, right? So probably getting two angles in this triangle would be ideal, right? We can do a lot of different things with that. So we can do that by realizing that we have supplementary angles here, right? We have a line here being intersected by another line, and the angle here is 106, and so we know the angle here is going to be 180 minus that. So we'll call this angle W, and 180 minus 106 is going to equal W, right? And so W there would equal 74. Okay? So since W is 74, I mean, we could add all of these angles up, right? And know whatever this angle is, right? We could set it to some variable T, right? Add them all up and know that they're 180. And from that, we could get T. And then we could use supplementary angles to get X. But that was something we did before, right? And I told you that was the longer way, right? We know the exterior angle theorem, which says that since, right, this is an external angle, right? It's supplementary to an angle in the triangle. The two opposite angles of that triangle are going to add to be this guy. Okay, we know that. And again, I can show you that when we're actually, I could even show you that right now, right? We know X, and we'll call this thing T, right? X plus T is going to be 180, and also W plus 23 plus T is going to be 180, right? And so X is going to have to equal W plus 23, right? And so that's, X equaling the sum of these two angles. Okay, so just to jog your memory there, because I know, listen, I wish that my professor would repeat stuff more, because, it's not like I get things the first time he says it every single time. Like, that's not a thing. But, all right, cool. So we're just going to add these two angles. We're going to add W, we're going to add 23, and that's going to give us our answer. We get that X is 74 plus 23, right? And that right there is going to be 97. All right? And that right there is our answer. Awesome. So that does it for problem 23. On to problem 24. We have that a laundry service is buying detergent and fabric softener from its supplier. The supplier will deliver no more than 300 pounds in shipment. Okay, so we see 300 pounds. So we're thinking it's, well, oops, wrong sign. There we go. Less than or equal to, right? No more than 300 pounds. So it can't be any more than 300. So we know we're dealing with something like that already. Each container of detergent weighs 7.35 pounds. And so we know we're dealing with a 7.35 times, what's the variable for detergent? Well, it looks like below D, right? So we're going to have a D. And then each container of fabric softener weighs 6.2 pounds. So the total pounds of fabric softener is going to be 6.2 times the amount of containers of fabric softener, which is labeled S. And we can see that from the answers, right? So the service wants to buy at least twice as many containers of detergent as fabric softener. Okay, so that tells us something too, right? We know that there's an at least, right? So something needs to be greater than or equal to. And this person wants to buy at least twice as many containers of detergent, right? So twice as many containers of detergent does not mean 2D. Okay, don't get caught up with that. And that's, you can see in the answers here, they're trying to catch you on that. They want to catch you on that exact thing. And you can also see here that they have the opposite going on. And so maybe that would just tell you to like pause and think for a second and be like, ooh, I could make a mistake here, right? Because think about it. You would actually want this to be D is greater than or equal to 2S, right? Because you want twice as many containers of detergent as you do fabric softener. So you would want to take the amount of fabric softener you have, multiply it by 2, and get the amount of detergent, right? Because this is double. Okay? If you don't believe me, just start plugging in values for S and you'll see, right? The amount of detergent is 2 more than because of the 2 here. So we have that, and really all we have to do here, to figure out the total pounds in the shipment is just add these two things, right? And so we get 7.35 D plus 6.2 S. Sorry if that looked like a 5, it's not. Is going to be less than or equal to 300. And we also have that D is greater than or equal to 2S. And that, my friends, is choice A. All right, awesome. Looks like we're doing problem. What happened here? Hang on. That's supposed to be an S. Anyways, looks like we're moving on to problem 25. Problem 25 says, in the equation above, T is a constant if the equation has no real solutions. Which of the following could be the value of T? Now, for this problem, we are trying to see, where the equation has no real solutions. So what are we going to be looking at for that? Well, that's the discriminant, right? That's the piece of the quadratic formula that determines whether you're going to get i's or not, whether you're going to get imaginary numbers. Because if you don't have any real solutions, that means you have imaginary numbers. Okay? And so we're going to look at that. That's the square root of b squared over minus 4ac. All right? Here's the thing. We, to find the value of T, right? Honestly, I would just start plugging in here. I would just start plugging in. What if T was -3? Okay, well, let's do that. 2x squared minus 4x equals -3. We add 3 on both sides. And then we use the discriminant, right? If we get a negative under the square root, we know that we're not getting any real solutions. B squared is 16, right? That's the -4 squared. Minus a 4 times A times C, right? AC. And that's going to equal, we have a 16, and we have 8 times 3 is 24. So this is equal to the square root of -8. So we get a negative under the square root, right? And that means that this equation has no real solutions if we have T equal to -3. So that's our answer right there. Okay. And now we're halfway done. We're halfway done. And just on like a side note here, I don't know if I'm going to be able to record the rest for just getting it out tonight. Oh, God. I'm tired. All right, so I'll make a deal with you guys. I will do another 5 problems, and then I'm going to go to bed, and then I'll do the rest tomorrow. Okay? So, we're going to move on to problem 26 right now. This problem says, in the figure above, segment BD is parallel to segment AE. What is the length of segment CE? Right? So this problem is saying segment BD parallel to segment AE, right? And then it says what's this segment right here? Okay. So you can probably see, the way these triangles are kind of like coinciding right now. Right? This is a similar triangles problem. Okay? And so you're trying to find the total length CE. Right? And this length, right? So you also know this length, right, of the little triangle. So it actually would probably be best, just to visualize this, because I feel like it's hard to show right now. I think I should just do this and show it like this. So you have a little triangle, and then you have a much bigger version. Right? And they're similar, which means that, you know, they're going to have a ratio, right? And so here the side, that little side is 6. Here it's 18, right? And then on the little one, this guy's 8. And we're trying to find this guy, this x, right? That's what we're really trying to find in this problem. So the problem is, you know, with similar triangles, right, we'd be able to find this side no problem. But, right, we just set up a ratio, right? It would be, let's call this side y, it'd be, you know, 8 over y equals 6 over 18, right? And we could just solve like that. And we could do that to get to x and then use Pythagorean theorem once we have this, or to make the numbers a lot easier, because again, this is still the no calculator part, right? You want to be making these problems as easy for yourself as you can. And so that's why I think it'd be really nice to use Pythagorean theorem in the smaller triangle and then use that to compare to the bigger triangle. If we use Pythagorean theorem in that smaller triangle, we just get 8 squared plus 6 squared is equal to c squared. Right, this is actually a Pythagorean triple, because if we look, 8 squared is 64, 6 squared is 36, that's equal to c squared, right? That added together is 100, and then square root both sides, and you get c is equal to 10. So this guy right here is 10. So now we can set up that ratio and be able to solve directly for x, right? And now we didn't have to go through all the trouble of using Pythagorean theorem when we had two big numbers, and this number would have actually been 24. So, you know, it would have been gross to use those numbers to use Pythagorean theorem with, right? Without a calculator. You could do it, but it would be really annoying. So now what we can do is we can set up that ratio. 10 over x is equal to, well, we could just use the sides we know, right? 6 and 18. 6 over 18. Now you can probably tell just from looking at this what x is going to be, right? X is going to be 30, right? Because this is 1 over 3. And so this would have to be 1 over 3. And to have that, you know, x would have to be 30. But let's say that you don't see it, which, again, it's not a problem, right? I mean, everybody's going to be at different levels right now. Okay? And so 10 over x is going to be 1 over 3. I would simplify that before finding common denominators, right? Just divide by 6 over 6. And then, sorry, I said common denominators. I meant cross multiplying. Jeez. Yeah, I do need to go to bed. 10 times 3 is going to be 30. And then 1 times x is going to be x. And so, yeah, you get x equals 30. Moving on to problem 27, we're asked if a to the b over 4 equals 16 for positive integers a and b, what is one possible value of b? Okay, now really here, right, we're given two different variables, okay? So don't think you're about to go just putting each sides to the 4th power, right? And then, because first off, I don't know why this is a 14, this is 4, right? When you put both sides to the 4th power, you're going to have to put a 16 to the 4th power. Obviously, you're not going to be able to do that. Okay, and you also have an a here anyway, right? So it's really weird. That's weird. You would only, if putting both sides to the 4th power, all you would do is get an a to the b on this side, and that really wouldn't do anything for you, right? So, you know, naturally seeing a fractional exponent, that was kind of my first instinct, and I was like, oh yeah, no, that's definitely not it, right? So here's the deal. With this, it's really just, you know, guessing a value of b that could work here. Just guessing a scenario in which this thing could equal 16. And the thing is here, we want positive integers, right? We're looking for whole numbers. We're looking for 2, you know, 3, 4, 5, whatever. But we don't want something like 7.25679, right? So think of a scenario, right? What to a power equals 16? Just think of it something like that. Well, okay, well, we know that 4 squared equals 16, right? That's really nice. So let's say that our a is 4, right? What value of b could give us a 2 here? Well, we could have an 8 here, right? And that would give us a 2 overall. So for b over 4 to equal 2, right? You could see there b is equal to 8. And so that's one of the possible values of b. Now you might have solved this in a different way, right? I mean, there are a couple different options here of what you could have done, but that's one of them, right? B could equal 8. All right, so that's problem 27. Problem 28 is a little bit tricky. It says how many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution. Okay, so now you're copying, like, you're combining chemistry with percents, and so that's got to freak you out looking at this problem. Like, I saw this problem and I was like, oh my god, I don't want to make a tutorial on this at all, but here I am on a Friday night at 9:30 at night. But anywho, and by the way, that's late for me. Anywho, what we want to do for this problem, it's not as bad as you would think it is. So we're seeing, how many liters of this 25% saline solution. I'm going to get rid of these percents right now and just say, well, the amount of liters, which we'll call X, times this 25 over 100, right? That's what we're adding in, okay? It's this many liters of this. And then we are going to add that to the 3 liters of the 10% saline solution, okay? And then we have, right, our total amount of saline solution, which is going to be X plus 3 liters. And the total amount is going to be 15% saline solution. Right? So hopefully you see, how I went and set that up. We know that we need 25% of a saline solution adding to 10% saline solution. Right? And it's just nicer to write fractions than percents. And we know we have 3 liters of this guy. We don't know how much of this guy we have. Right? That's what we're trying to find. Right? And in the end, we want to get that 15% saline solution. And at that point, we would have X plus 3 liters. Right? Because it would be, the amount of liters here plus the amount of liters here. Okay? A little weird to set up, but once you get it, you get it. Okay? So now what we do, we have 100 in the denominator everywhere here, so really that can just go away, right? This X can be put up in the numerator here, and so could the 3, right? You could just put that up in the numerator. It really doesn't matter. So we could actually just get rid of or you could think about it as multiplying by 100 on both sides, right? We could write this as 25x plus 3 times 10, 30, equals the 15 times x plus 3. Right, we can just get rid of those over 100s because they're everywhere. So now we have 25x plus 30 is equal to the 15x plus 45, right? We just distribute that 15 through. And then we solve for x, right? And here it just becomes a quick equation. We can subtract 15x on both sides. We can also subtract 30 on both sides. And then we get 10x, this goes away, equals, this goes away, 15. And dividing by 10 on both sides, we get x is equal to 15 over 10, which is 3/2. Okay? So that's it for problem 28. Moving on to problem 29. We have that points A and B lie on a circle with radius 1. So let's write that. Oops. Sometimes it works, sometimes it doesn't. So points A and B lie on a circle with radius 1. So we'll draw a circle here, radius 1. And we have that this arc AB has a length of pi over 3. Right? So this arc right here, AB, length of pi over 3. Okay? Awesome. So it's saying what fraction of the circumference of the circle is the length of arc A and AB. Right? So what fraction of this, what fraction of the circumference of the circle is this piece right here? Okay, well, we don't know what the circumference of the circle is, do we? Can we find it? Yes. We know that the circumference is equal to 2 pi r, or pi d, right? And using that, we know the radius here, right? That's what, I mean, if you're looking at this and you're stumped, right, you're like, okay, well, how can I incorporate the radius here? Well, that's exactly how. We know circumference is pi d, which is 2 pi r, right? And so plugging in the radius that we know, I mean, we know it's 1, so it would be 2 pi. And so the little mini guy here, the little arc, that's just pi over 3. So what fraction is that of 2 pi? Right, which is the circumference of the entire circle here. Well, this is just dividing two fractions, right? It's 2 pi over 1 is how you can think of it. And so you do, you could say keep, change, keep, change, flip, or whatever y'all say now. I think we said stay, change, flip. But you're going to flip this guy and put it up in the numerator, right? And so this is equal to pi over 3 times 1 over 2 pi. The pi's cancel, and you're left with 1 over 6. Okay, awesome. So now we're going to move on to the last problem for me for tonight, but you might still keep going, grinding it out here, and I respect that. The graph of a line in the xy plane passes through the point 1, 4. And it crosses the x-axis at 2, 0. Right? The line crosses the y-axis at the point 0, b. It's going to be up here somewhere. What's the value of b? So this is just a line, right? And so this is actually going to be pretty similar to one of the problems we had before. This is just going to be rise over run, right? I mean, this is the same idea. If I just move all these over here, right? It's the idea of, well, to get from here to here, right, or to get from here to here, we had to move upwards by 4 and move over by -1. And then to get from here to here, we just move upwards by 4 and then over by -1 again, right? And once we've done that, we are at what? Well, we're at 0, comma, add this 4 to this 4, and you get 8. And so b equals 8. Right? It's just a quick little problem. But anyways, yeah, so that's going to do it for me for tonight, and I'll see you in the morning. All right, and we're back. So I switched it up to a flannel now because I'm getting tired of the whole polo thing. But yeah, so now we're moving on to the calculator problems. Let's crank those out, and then that will be it for the video. All right, so problem 31 here. This is a little weird, right? It gives us an equation, right, with a's and b's in it. It says, and x's. This is based on the equation above. What is the value of ax plus b? Okay, so looking at this here, right, usually you're used to being asked something like, okay, what's the value of x, or what's the value of w, or what's the value of y, right? But here we're being asked for the value of an expression, right, ax plus b. Okay, and so we need, to solve for x, to solve for y, to solve for ax plus b, right? Same idea. We need to isolate these things, right? And so here we're solving for x plus b. We're going to isolate that. And how do we do that? Well, we can factor out a 9 here. I think that's a great way to start. And actually, let me just write this out so it's a little bit bigger. Right? We can start here by factoring out a 9. And that will get our ax plus b so it's together. Right, and then we have -6 equals 21. Okay, and yeah, putting that together, right, it is going to be the first part, and then we're going to get it by itself. So to do that, we can just treat this like as if it was like an x, right? If the entire thing was an x, or if, since we already have an x here, you can think about it as like a 9u minus 6 equals 21, right? We're just solving for u. Okay, so what we do right here is we add 6 on both sides. And in doing that, we get that 9 times ax plus b is equal to 27. Then the last thing we need to do to get ax plus b by itself is going to be to divide by 9 on both sides. And when we do that, we get that ax plus b is equal to 3. All right, and that right there is choice A. Okay, so, just try not to think of this really that much differently than solving for a single variable, right? The only real difference here was that first we had to actually, get this expression together, right? And we could do that by factoring out the 9s here. And then we were able to isolate it just like we would for any other variable, okay? So that's problem 31. Moving on to problem 32 here, it says in the figure above, what is the value of x? And well, here we have a four-sided figure, right? We have 1, 2, 3, 4 sides. And so it asks for the value of x. Now, we know that all the other angles that aren't 45 are the same angle, right? And we also know that in a four-sided figure, right? In a four-sided figure, all the interior angles are going to add to be 360. And since we know this, what we can do is do, 45 plus all the other angles, right? X, x, and x, or you could write that as 3x. We'll do that in the next line. But then, this all added together is going to equal 360. And so now you have an equation to where you can just solve for x, right? And so let's do that. We get 45 plus 3x is equal to 360. And then we can subtract 45 on each side, right? Solve for x. Oops, something's bugging out. There we go. Right, so subtract 45 on each side, we get that 3x is equal to, is actually going to be a 315. Okay, and then we divide by 3 on both sides. And when we do that, we get that x is equal to, well, you don't really need a calculator for this. You can use one. When I say you don't need it, I mean just trying to use mental math here, right? You could break this up into a 300 divided by 3 and a 15 divided by 3, right? And this is 100, this is 5, so this is 100 plus 5, and this is 105, right? And once you start doing mental math like this a lot more, well, this is going to become a lot more natural to you, and you won't have to write it out, right? But again, if you use a calculator on this, it's it's not a big deal. It's fine, right? Like there's no harm in that at all, especially since now we're in the calculator problems. So that is going to be our answer here, 105, and that is choice D. So now we're going to move on to problem 33, and this problem says a customer paid $53 for a jacket after a 6% sales tax was added. What was the price of the jacket before the sales tax was added? Okay, so here's something that you can't do for this problem, okay? I think a lot of people would just automatically guess that, you do 53, if you're trying to say, okay, well, this is the product of that 6% being added, right? So we can just subtract that 6%, right? We can do this times a 1 minus 6%, right? But that's not it, okay? That's not how this works. Okay, how you actually would do a problem like this is, well, you would say, how would we get that 53 in the first place? If we're adding that 6% to some value, right? That's what we're trying to find, is the value before the tax. And so we can do, let's call it x, and we'll multiply it by 6%, right? And when I say that, right, we're increasing this value by 6%. So this isn't just going to be a 0.06, right? Think about it. If we multiplied x by 0.06, it would make this thing a heck of a lot smaller, right? That's not what we want. We want to increase the value of x by 6%. And so what we do is we add 1 to it. Okay, and that gives us our 53. Okay, and just a little more on why that happens, why it's 1 plus 0.06 versus 0.06, right? Think about if it was just the 1. right? Like think about if it was just x times 100%. That's what 1 is, right? Well, that would just give us our x back, right? Then let's say 106%. So let's add that 6% in, right? That's going to be a 6% increase from 100%, from our original value. That's why we do that. And hopefully that just clears things up a little bit. I know that I always got tripped up when I was in algebra and doing all that stuff because I wouldn't understand, why we would use 0.06 in some cases and why we would use 1.06 in other cases. So this becomes 1.06x equals 53. And dividing by 1.06 on both sides, you get that x is equal to, and just put that in your calculator there. You get 53 divided by 1.06 is 50. Okay. And that right there is your answer for problem 33. Problem 34 is a scatter plot that we're given here. And it says this scatter plot above shows data for 10 charities along with the line of best fit. For the charity with the greatest percent of total expenses spent on programs, which of the following is closest to the difference of the actual percent and the percent predicted by the line of best fit? So this problem is wordy, right? This problem is very wordy. And so when I was originally reading this problem, it did take me a little bit to just kind of piece out information. But, what you want to do is kind of divide, like you do for pretty much any other word problem. You want to take out the little, sections that are giving you little bits of information and then just try to digest them separately, right? Because trying to digest this entire thing all at once is definitely a nightmare, right? So you want to break it up into pieces. This first sentence here, really, it's whatever. Okay, we get a line for best fit, right? We're talking about charities, cool. For the charity with the greatest percent of total expenses on programs, right? Which charity is it talking about here? Well, each one of these dots, right, represents a charity, okay? And percent of total expenses spent on programs is the y-axis here. So if we're trying to see which one has the greatest percent of total expenses, well, would be the one that's highest up on this axis, right? And that's this charity right here, right? And so now we have that charity, and it says which of the following is closest to the difference of the actual percent, right? So whatever percent we have here, and the percent, so that's actual percent, and the percent predicted by the line of best fit, okay? So the line of best fit is down here, right? That's this line. And so the percent predicted by the line of best fit looks like it's a little above 85, right? So let's say 85. Okay, what was this guy up here? Well, it would be, looks like 92, right? Around there. And if you actually go and find their difference, right? Subtract them, you get the difference here, how far off this line of best fit is from the actual value, 7%, right? I mean, this is 92 minus 85 is 7, and so 7% would be your answer here. Moving on to problem 35 here, we have a table that is giving us the percent of residents who earned a bachelor's degree or higher, okay? The problem says a survey was given to residents of all 50 states asking if they had earned a bachelor's degree or higher. The results from 7 of the states are given in the table above. The median percent of residents who earned a bachelor's degree or higher for all 50 states was 26.95%. Already I'm seeing the words median, I'm seeing 50 states, I'm seeing 26.95%. So just making a note of all that information, right? We know 50 states is going to have a median of 26.95%. That could probably play a role later in the problem. We'll see. What is the difference? Okay, so we're asking for a difference now between what? The difference between the median percent, actually I'll highlight this now because it's a different sentence. What is the difference between the median percent of residents who earned a bachelor's degree or higher for these 7 states and the median for all 50 states. So here it looks like we're trying to find the median for 7 states and subtract the median for 50 states. Right? That's what the problem's asking for. We know what the median is for the 50 states, but we don't know the median for 7 states, and that's something we can quickly find. Now, like a lot of problems on the SAT, right, there's a shorter way to do this, a quicker way. There's also a longer way, right, which, might save you, well, it might save you like 30 seconds to do the shorter way, right? But doing the longer way, not a problem, especially if you struggle with this type of stuff, okay? So don't worry too much about that, all right? Because I don't want you to start stressing out about finding the quickest way possible every single time if you don't feel comfortable with this stuff to begin with, right? It's one step at a time. So the longer way to do this would be to actually write out a list, right? And just write out, to find the median, right? We know that's the middle number, but it's the middle number when this thing is like in order, right? It's in order from least to greatest. So we could write 19.5 is the smallest here. Then we have 21.9 and looks like 25.9, 27.9, 30.1, 35.5, and 36.4, right? And so all we would have to do here is start crossing off, right? 1, 1, 2, 2, 3, 3, and now we find our middle number. It's 27.9. So that's going to be our median for 7 states. Okay? But the quicker way that we could have done this, we didn't actually have to write out this list at all, right? And actually, I'll keep this up just for your reference. But we could have just crossed off using this table and started by, let's say, we cross off the lowest one. We crossed off one of the lowest ones. We cross off the highest one, right? 1, 1, and then cross off the next lowest, cross off the next highest, cross off the next lowest, cross off the next highest, and there you see we have 27.9, right? So you can kind of just like think about it in your head, okay? But again, either way works. It's all what you're comfortable with, okay? Awesome. So the median for 7 students is going to be 27.9%. And we want to subtract the median for 60 students, or 60 states, which is 26.95%. You can put this in your calculator if you want. I mean, don't include the percents because that's just going to be a hassle. But yeah, if we just subtract these two, we're going to get 0.95%. You might already be able to see that without putting it in your calculator. Okay, that's choice B. All right, so we finished another set of 5. We only have 15 problems left in this video, and so don't burn out now. Let's just focus on getting those next 5 done. All right, so we'll get 36 through 40, and I'm also wearing a new flannel here. I don't know why I'm still announcing this. Anyways, let's move on. So moving on to problem 36 here. We have in the figure above, lines L and M are parallel, y equals 20 and z equals 60. What is the value of x? Okay, so we know that y is 20. We know that z is 60. And we're trying to find x. Okay, so how would we go about doing that? Well, we can see here that we have this like little triangle, and you guys are probably eyeing this thing up, right? And well, if we knew this angle, we could just, since we know this angle too, we could add them up, and well, x added to those would have to be 180, right? Because all angles in the triangle had to be 180. So that's what I'm thinking about right now. I'm thinking about finding this angle, and we actually do know this angle. It's going to be 20 degrees. How do I know that this angle is 20 degrees though? Well, that's because, actually let me use the highlighter here. This angle and this angle are corresponding angles, okay? They are going to have the same angle measure, okay? I mean, I guess a more complicated way to think about this, of why that actually is because, let me get in a different color here. This angle and this angle are going to be the same because they're alternate interior angles, right? And, well, this angle and this angle are vertical angles, so they're going to be the same. And so, yeah, you get that this angle is equal to this angle. If you want to think about it like that, maybe that's a better way, just to help your mind make sense of it. But yeah, so now we know that, oops, gotta pick the white. There we go. 20 degrees and 60 degrees are the two angles of the triangle. And so we know that together we get 80 there. And so 80 plus x is going to equal 180, right? That's all the angles in the triangle. So we subtract 80 on both sides, and we get that x is equal to 100. Okay? And that right there is choice B. So let's move on here to problem 37. And problem 37 says that x plus 1 is equal to 2 over x plus 1. And it says, in the equation above, which of the following is a possible value of x plus 1? Okay? And so we have a bunch of different answers here. Now, you might look at this problem, get confused and be like, okay, well, how am I solving for x plus 1 here, right? It's kind of the same thing as when we solved for ax plus b earlier, right? It's kind of the same idea where you're solving for an expression rather than a variable here. But you might think of a couple different ways to start solving this, right? You might think of solving for x plus 1, and you could do that, right? But I think the way that a lot of people would go here is just by plugging in the answers. But here's the problem with plugging in the answers. I think a lot of people are going to start using that tactic. They're going to plug in a, right? Because that's what most people start out doing. And if they plug in an a everywhere they see a x plus 1, you're going to get this thing, right? And that looks gross. And a lot of people will get scared. They won't know what to do with that, right? And I get that. So what my suggestion is to you is to look at the other answers that are they look better, right? Deal with those answers first before you get into one that looks really messy. Okay, just to limit the confusion that you're going to face during the problem. Okay? And so let's just plug in b, right? That looks a little nicer, at least a lot nicer than 1 minus rad 2, right? And we can do that. We can plug that in. If we plug in rad 2 for the x plus 1, we're going to get a rad 2 equal to 2 over rad 2. Now, we can simplify this here, okay? Remember that we can write a 2 as a square rooted 2 as 2 to the 1/2, right? It's power over root, remember, power over root. So we have a first power here and a second root, okay? And a second root is a square root. Okay, so we have 2 to the 1/2 equals 2 to the first power over 2 to the 1/2 power, right? Just continuing that on for this side. And, well, if we're going to, these have the same base here, right? So we can just subtract the exponents, and 1 minus 1/2 is, well, 1/2. And so we get that both sides are equal to each other. So the answer here is going to be choice B, because rad 2 could be a possible value of x plus 1. It worked, okay? And I don't want to just show you one way to solve this problem, because you could have what you could have done, and some people might find this way easier, right? You could have just solved for x plus 1. How would you do that? Well, you could take this x plus 1 equal to 2 over x plus 1, and you could just multiply each side by x plus 1, okay? And so, oops, let me make room. Okay, and we would get that x plus 1 squared is equal to a 2 over x plus 1. Or sorry, just a 2. That's the reason why we multiplied, to get rid of these. And then all you have to do is square root both sides. And in square rooting both sides, you get that x plus 1 equals plus or minus rad 2. Right? And yeah, both of these, if you plug in a negative rad 2, it would work as well. But here's the thing, our answers don't have a negative rad 2. It only has a positive rad 2, right? And that makes sense, because there's no question on the SAT where there's 2 possible answers, right? It's always just one answer. And so, well, when you're dealing with multiple choice, there's just one answer, is what I meant to say. And so we're going to go with the positive case here. And so that being x plus 1, right? We're not solving for x here, we're solving for x plus 1 is going to equal rad 2, and that is choice B. Okay, so that is problem 37. Problem 38 gives us the ages of 20 students enrolled in a college class, right? I always like to read the title of the table first. The table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? Okay, so look at what graph we're given here. Okay, because I would say originally this thing would be a nightmare if we were just given a list and then we had to order that list and then we had to do a bunch of stuff like, especially finding the mode. It's annoying. But here we're given a frequency graph. We're given how many times the 18 pops up, how many times 19 pops up, how many times 20 pops up, right? And so that's going to help us right away find our mode, right? The mode is the number, right? In this case, the age that appears the most. Which age would that be here? Would be 6, right? It'd be that's the age 18. So the mode here is 18. All right. What about the median, right? I think that's a nice second one to deal with. Well, there's a couple different ways that you could do the median. Again, just like we did before with our last median question, there's a short way, right? A nice quick way, and then there's also a longer way. Okay, and it all depends how comfortable you are with this kind of stuff. You could actually put this all out in a list and do 18 6 times, blah, 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 19 5 times, and then 24 times, and then just start, crossing off and eventually getting to your middle number, right? That's what the median is. But what you could also do is kind of just do this in your head a little bit and just kind of count, right? Okay, well, I'm going to cross off 6 here, so I need to cross off 1, 2, 3. This is going to make it 5, and then this would make it 6, right? And so then if I cross off the 3 here, right, I cross off 3 here, I'm left with 2. And so the middle number, right, is going to be in the age 19 row, okay? Because we've crossed off all our numbers everywhere else. Okay, hopefully that makes sense. That's just how I would think about it in my head. So the median here is 19. That's going to be the middle number of this table. Then lastly, we need to deal with the mean. Okay? And to find the mean, what I would do is, well, instead of writing, 18 plus 18 plus 18 plus, and then doing that on, and then saying plus 19 plus, and then dividing by the number of students in total, which is 20, you could make this a lot more compact. And how you could do that is by saying, well, instead of writing 18 6 times, we could just do 18 times 6. And then we do 19 times 5. Right? We do 20 times 4, and we just multiply each age by its frequency. Okay, if you actually, and if this is not making too much sense to you, if you actually go out and, write all of this completely out, you'll see that it's the same exact thing. Okay, it's a nice little trick that you can do. Okay, and then this is going to be just something giant that you plug into your calculator. Okay, instead of course, don't include the multiplying by 1. That would just be a waste of thumb movement. But yeah, when you actually go and plug all this in, you get that your mean is 20, right? And so that the mean is the greatest, the mode is the least, and which one has that? Well, it looks like choice A, right? And which color are we on? We're on blue. So give this a nice circle in blue. Okay, and so that is the answer for this problem. Okay, just realizing that we have a frequency graph is really, really helpful. Okay, we can go through and we can, rather than a list, right? If we had a list here, this would be gross, but we have a frequency table, and that's really nice. So when we do that, we can find our mode, median, and mean, and then we can, just figure out our answer. So that's problem 38. Let's move on to problem 39. This one is a lot quicker. It says, which of the following is a value of x for which the expression -3 all over x squared plus 3x minus 10 is undefined? So here we have that we're looking for where our fraction is undefined. Where is a fraction undefined? Well, a fraction is going to be undefined where it has 0 in the denominator. So this is actually just going to be a problem of finding where the denominator is 0, right? And the denominator is a quadratic. And so you can assume here, yeah, we're just solving the quadratic like we usually do, right? And here's another thing. Look at our answers, right? Our answers are all nice numbers, right? There's no square roots or just disgusting looking things. And so that means that we're going to be able to just factor this really nice and easy. We don't have to use quadratic formula and go through all that and, you know, have that hassle of plugging that all into our calculator, right? We can just factor this really nice. So when we actually go and factor this, what are two numbers that add to be 3 and multiply to be -10? Well, 5 and -2, right? And so x is going to be equal to -5 and x is going to be equal to 2. And well, looks like we have 2 on the as one of our choices. So that is going to be the answer for problem 39. Okay? So, you know, and listen, I get that a lot of people have trouble finding those factors still, okay? And here's what I would do. I would say, okay, you know, if you're having trouble finding these guys, just find all the different things that multiply to be 10, right? You could be thinking about 1 and 10. That's a good first start. And so if you see this thing as being like 1 different than this, right? Like, so you see this thing as being a 9 or an 11, right? You might be thinking, okay, the 1 and 10 is going to work. And then what else multiplies to be 10? Well, you can think about 5 and 2, right? And that's what led to our answer. Okay, so I would always start with the multiplication thing, all right? That's what I would go with. Problem 40 gives us a system of equations, and it says, for the solution xy to the system of equations above, what is the value of x minus y? Okay, so for this problem, we need to find our solution, because we don't know what that is. And once we find our solution, we're not done. We need to actually find what x minus y is. Okay, so let's go through and just solve the system of equations. It shouldn't be that bad because as you can see here, we have a plus 3y and a minus 3y. So let's add these together. And you can see here that we get, well, 13x, right? These go away. And we get that this is equal to 13. And then we can just divide by 13 on both sides. Doing that, we get x equals 1. And now we can use that, plug into one of our equations. I think we can plug into the 6 one. I mean, I just like the one with the smaller numbers. And so we get 6 times 1 minus 3y equals 5. Let's solve for y. We get 6 minus 3y is 5. Subtract 6 on both sides. -3y is equal to -1. Divide by -3 on both sides. Right? And we get that y is equal to 1/3. Okay? So remember here that we're trying to find x minus y. We're not trying to find x, we're not trying to find y, we're not trying to find them together. We're trying to find x minus y. So the last step here is going to be to actually do x minus y, right? X is 1, y is 1/3, and then if you just subtract these guys, you're going to get 2/3. Okay? And that right there is choice B. All right, so that was another 5 problems completed. Now we only have 10 problems left in this entire video, and then we're done with 50 entire practice problems. Okay, so let's focus on just getting these next 5 done, right? Well, let's get to 45. Our next problem, problem 41, says which of the following equations relates y to x for the values in the table above? Okay, and we can see in our answers here, right, we're given two functions that are exponential functions, right? And we're given two lines, right? These are linear. Okay, how do we know that? Well, these are, something to the x power. And then here we have just our slope, right? And it just looks like y equals mx plus b form. Right? You could see, our slope, our y-intercept, slope, y-intercept, right? Awesome. So, cool. Now what do we do? How do we figure out which ones, if it's exponential, if it's linear, how do we know? Well, let's just look at how much we're increasing in the y for each step we take in the x direction. Well, looking at it here, you can kind of see a trend, right? You can see that we're kind of just adding 14 to the numerator every time, right? And if we're increasing by a constant amount every time, that's linear. That means, remember what I've talked about earlier in this video, right? When we increase by constant amounts, that is a line. That's what a line does, right? It's the same rise over the same run every single time, okay? So it's definitely not exponential, and that's what we can already say. So how do we figure out whether it is this line or this line, right? Well, you can see that their slopes are different, and also their y-intercepts are different, and so I guess it really doesn't matter which one we try to find right now. You could find the slope. I mean, you can kind of already tell what it is, right? You just do the y2 minus y1 over x2 minus x1, right? You know that the change in x is just 1 every time, right? You're just increasing by 1 because you have, let's just take these first 2 points here, right? You'd have 2 minus 1 in the denominator, and you'd have 25 over 4 minus 11 over 4 in the numerator. And that gives you a 14 over 4 all over 1. And so you know your slope, right? M is going to be 14 over 4. Right? And that reduces to 7 over 2. Right? Just dividing by 2 over 2 here. So that is choice D. And so I kind of went through that a little quick. I apologize for that. But I did want to show you another method too. And we could have found the y-intercepts here. Right? All we really had to do was say, well, where does the y-intercept occur? Well, it occurs right at x equals 0, right? It means we haven't moved at all in the x direction, so we're at x equals 0, right? And so where, what's our y coordinate at x equals 0? So we could have looked at this table, right, and been like, okay, well, we know that we've been increasing by 14 over 4 each time, right? And so I guess you would have already had to know your slope, and then you could have just identified it. So this is I think that this is the longer way. But if you wanted to think about it, we could have just subtracted 14 over 4 to the 11 over 4 and gotten negative 3 over 4 and realized, okay, yeah, that's where our y-intercept is going to be, right? Because if you just subtract 1 from the x here, if you move over left by 1, you end up on the y-axis, or you end up at x equals 0. So, it's up to you, but I think that the slope method is a lot quicker, and that's what I always opt for anyway, right? The y-intercept is almost never the quicker way. So, moving on to problem 42 here. We have two triangles, and it says triangles ABC and DEF are shown above. Which of the following is equal to the ratio BC over AB? Okay, so looking at these two triangles here, right, we're given some angle measures, and so you can assume that there's something we need to do here, and we also know that they're both right angles, right? And just looking at this, right, I can see that, like if we're thinking about ratios, right, that might trigger something in your mind to think about similar triangles, right? When we're talking about ratios between two triangles, that's similar triangles, right? And so maybe these are similar triangles. Let's look at those angles. If those angles match up, then they are. Well, since these are right angles, right? This and this are right angles. We can find that other angle of these triangles, right? Here, in this triangle over here, we know that 32 plus 90 plus whatever that other angle is going to equal 180. And so we see that we can, subtract 32, subtract 90 here. You could add them together, right? Here you'd get that x is 58. And so this missing angle right here is 58 degrees. So that means that in this triangle, since we have a right angle in 58, this missing angle would be 32. And so what you can see here is that these are the exact same triangle in angle measure, right? That doesn't mean that they're congruent all around, right? That would be angle, 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 if you can remember that from geometry, and that's not a postulate that you can use to prove congruence. Okay, so what we can see here is that they're just oriented differently, right? It's the same triangle angle-wise, they're just one's flopped on its side. So looking at this now, we can find this ratio. What is BC over AB even referring to? Well, BC is right here, AB is right here, and what are those two sides? We'll use yellow here. What are those two sides on the other triangle, right? Well, the hypotenuse would be DE, and the small side would be DF. And so, if I write this with color, right, BC over AB is going to equal DF over DE, right? We're just using the corresponding parts. And so that right there is going to be your answer for this problem, and that's choice B. Okay? Awesome. So moving on to problem 43 here, we have that a study was done on the weights of different types of fish in a pond. A random sample of fish were caught and marked in order to ensure that none were weighed more than once. The sample contained 150 largemouth bass, of which 30% weighed more than 2 pounds. Which of the following conclusions is best supported by the sample data? Okay, so we have a bunch of different statements here, and, well, let's look at them. Let's look at A, right? It says, the majority of all fish in the pond weigh less than 2 pounds. Well, looking back at this, we were just given 150 largemouth bass, right? We weren't given these other fish. So we can't make conclusions about the entire, the entire pond, every fish in the pond, just because of one of the populations of fish in that pond, right? We only are given largemouth bass, okay, which are going to have their own unique weight and everything. So we can't make conclusions about all fish from this, and that's what B and C are asking for, right? And so if you just identify that problem here, all fish versus largemouth bass, well, yeah, that's going to lead you right to your answer, which is the only one that talks about largemouth bass. And you can even do a sanity check here. Yeah, approximately 30% of all largemouth bass in the pond weigh more than 2 pounds, right? That's exactly what it says in this sentence, right? Of 100, the 150 largemouth bass, 30% weighed more than 2 pounds. That's literally what, it's just word for word what it says in the problem. So yeah, choice D is going to be your answer for 43. Moving on to problem 44. This one is going to be a little more work than we've been doing in the last few problems, okay? It says, in the xy plane, the graph 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? Okay, so remember how we actually find the equation of a circle, right? The equation of a circle, you're going to have something like, x minus a squared plus y minus b squared, right, equals your radius squared, right? You're going to have these different pieces. And so how do you get this guy into this form? Well, what you do is you complete the square, right? So that's right, we're going to have to complete the square here. I'm sorry, but this is good review for you. So let's start off here. We're given 2x squared minus 6x plus 2y squared plus 2y equals 45. And you can see here, this is really gross. We're given like 2s and 6s, right? These are all multiples of 2 on this side. And of course, it's going to be hard to complete the square when we have something out front of the x squared anyway. So what I would just do is divide both sides by 2 to make your life a heck of a lot easier. Now dividing by 2 on both sides here, we're going to get x squared minus 3x plus y squared plus y is equal to 45 over 2. Okay, and now we can start to complete the square. And how do we do that? Well, we're going to have to do it twice here, for the x's and for the y's. How we start completing the squares, we're going to put this thing into x plus b over 2 squared form. Okay, so the b is the number that comes in front of the x, and here that's -3. So this thing becomes a x minus 3 over 2 squared. But here's the problem. When you expand this thing, you're going to get x squared minus 3 halves x minus 3 halves x plus a 9 over 4. And so what happens is, I mean, combine like terms here, you get x squared minus 3x plus 9 over 4, right? And so you have what you had before, right? You have the x squared minus 3x, okay? But you also have this 9 over 4 here. And so this thing is not equal to this thing. So what we do to get this thing equal to this thing is we're going to need to get rid of that 9 over 4. And how can we do that? Well, we just subtract by 9 over 4, right? And since this thing is this thing, we just end up putting the 9 over 4 outside, okay? And so let's do that again here. Let's do that for the y's now. We get y plus, this is a 1 on the y, so we write this as just b over 2, so that'd be 1 over 2. And again, thinking about expanding this out, right, you'd get a y squared, you'd get a plus y, sorry, right, you recover your first 2 pieces, but what's your extra piece that comes out of here? When you do the 1/2 times 1/2, it's going to be 1/4. So you got to subtract that. Okay? Now, another way you could have thought about it is you could just think about like already adding it to the other side. So, okay, now we've added 9/4 to the one side from this guy, so we're going to have to add to the other side as well. That does save you a step. I don't want to get into that right now. If you're comfortable with this explanation, let's stick with it. All right? So let's add the 9 over 4, and let's add the 1 over 4 to both sides. And the reason why we're doing that right now is because, well, we need to get into that form of just having this thing and this thing on the left-hand side. So in the end, we get x minus 3 over 2 squared plus a y plus 1/2 squared equals a 45 over 2 plus 9 over 4 plus 1 over 4, right? And just finding common denominators here. I'll duplicate this. And you'd get 45 over 2 plus, or actually, we would want to make this a 4. So we'll do 90 over 4. Right, we just multiply this thing by 2 over 2. And we'll multiply by, or we'll add 9 over 4, we'll add 1 over 4, and so we get 100 over 4. Right? And so really, this thing ends up being 25, right? That's what 100 over 4 is. So remember, this thing right here is our radius squared. It's r squared. So what the heck is r? Well, r would be the square root of this thing, right? And so our radius here would be 5. Okay? That's choice A. Awesome. So that is it for problem 44. Now let's move on to the last problem of these 5, which is problem 45. And that problem says, in the xy plane, the graph of y equals 3x squared minus 14x intersects the graph of y equals x at the points 0, 0, and a. what is the value of a? Okay, so try to get a picture of what's going on here, right? You can graph it if you want, or just draw like a sketch of a parabola passing through a line, right? And remember that these things intersect at the origin, right? So that parabola is going to be passing through the origin, and that line is going to be passing through the origin, okay? So let's try to graph and just get an idea of what's going on here. No, I don't know exactly what this graph looks like, okay? But I'm just going to, we know that this 14x right here is going to like shift it off center, so it's going to be over here somewhere, right? So we can just draw some random parabola that passes through the origin, right? Something like that. And let's draw a line. Well, we know the line's y equals x. It passes through the origin. So there are two intersection points. There is 0, 0. And then the other intersection point is AA. Okay? So, just having an idea of, and you don't need the actual picture to solve this problem. It's not going to help you. Okay? It might help you to understand what's going on with this entire problem as a whole. But to actually solve this quick on an SAT, no, you don't need the graph. The reason why I'm doing this is because for other problems, maybe this would be a lot more useful. But in this problem, again, you can just set these things equal to each other, which we are about to do here, and then find the two intersections. Okay? So again, it's just a lot of these problems in this video, I've just been explaining them in the entirety, not really just explaining them just for speed. So to find intersection points, we are going to set these things equal to each other. Okay? And we can just then say x equals 3x squared minus 14x. We can subtract x on both sides and get that 0 is equal to 3x squared minus a 15x. Then we can factor a 3 out and get, actually we can factor a 3x out even, and get x minus 5 left over. That's what I would do here. I'd factor that out. That 3, you see, we have an x that we can factor out here and here. So that's nice. Now, we know here that either 3x has to equal 0 or x minus 5 equals 0. So there's two solutions, right? 3x can equal 0 or x minus 5 can equal 0. And when that happens, this entire thing will be 0. So anyways, we can divide by 3 on both sides to see that x would have to equal 0. We can add 5 on both sides to see that x would have to equal 5, and those are the two places. So we know that that makes sense, right? The x equals 0 is good because we know that that is one of the solutions. But we also get x equals 5, and so 5 is going to be this x coordinate, right? And so it's going to be the a here. Now, we don't need to find the y too because we know that from this point, right, the x is the same as the y. They're both a. And you can even do a sanity check here. That would make sense with y equals x, right? If this is equal to 5, this is to be equal to 5. So we can see here that a is going to equal 5. Alright, so it looks like we're almost done with this video. We've gotten another set of 5 done, and now we're on our last set of 5 problems for this video. Let's get this done. Okay, so this problem is going to be one where we definitely talk about speed a little bit more, because you can see here that this problem just looks really gross, right? We have decimals and we're going to have to expand this, and it just is gross, right? So we're going to talk about speed here, okay? But first, let's just do it out the normal way, okay? We can start by squaring this guy, right? Meaning that, and we're not squaring this guy. Notice that there's no 2 here. So this guy's going to become 1.5x minus 2.4 times 1.5x minus 2.4, right? Minus the, and you don't even need the parentheses anymore because you can just distribute this negative through, right? We can get minus 5.2x squared plus 6.4. Okay, and then we can distribute all this through here. Again, this is the slower way to do things. If we multiply 1.5 by itself, we're going to get 2.25, and this is going to give us an x squared. If we multiply the negative 2.4 by the 1.5, oops, just got to put that in my calculator here, we're going to get negative 3.6, and we're going to get two of those, right? We're going to get that one, and we're going to get that one, right? So we're actually going to get negative 7.2x. And then we can do negative 2.4 times negative 2.4, and that's going to be a positive 5.76. Okay, and then we have minus 5.2x squared, and we have a plus 6.4. Now, when we add together, we combine like terms, we're going to have a 2.25 minus a 5.2. And that gives us a negative 2.95x squared. Okay, we have just that negative 7.2x is going to stay there. Okay, and then we have a 5.76 plus a 6.4. And that gives us 12.16. Okay, and that right there is choice C. But notice how that problem just took us like a couple minutes, right? We probably should be doing, I mean, I don't want to worry you or anything, right? But we could do this problem a little bit faster, okay? And how we could do that is by, well, just looking at our answers here and being like, all right, well, all we really have to do here, we can find what the first bit is, right? By just multiplying 1.5 by itself and then subtracting 5.2. And then we could also, I mean, once we have that, we either know if it's these group or this group. And then these both have the same middle term. So we just need to focus on this last term here. Is it a 12.16 or is it a 0.64? Well, I don't know. Let's multiply negative 2.4 by negative 2.4 and then add 6.4 to the end. And that's how you would get 12.16. So just by picking and choosing what you multiply, right? If you already feel comfortable with this, if you already see it coming, then yeah, go through and do that and finish the problem quick and move on to the next one. Okay? Should only take you about a minute if you do that method, right? Maybe even less, and that'd be even better. Okay? So I just want you to understand that there are faster ways to do this. Again, I just want to do everything really, complete because I want to make sure everybody's on the same page here. Okay, everybody understands at least how to do the problems in the first place before I start talking about the tricks. It's been weird for me making these videos because, it's always like what level do I want to teach this thing at? Do I want to teach where I assume people are comfortable with all this algebra stuff? Well, I don't think that's the majority of you. So I'm going to, teach at that level where you might be uncomfortable with a lot of this algebra stuff still. And that's fine. Like, we'll get through it, right? So the next problem we have is in triangle ABC above, what is the length of segment AD? Okay, so for this, we're given, we can see there's two right angles right here. And you should already be able to see here, right? We have a 30, 60, 90 triangle, right? This one's going to be 30 here too. Once we know two of these angles in the triangle, we know that the other one's going to be, well, 180 minus these two, right? And hopefully you can already see how these would be 30, 60, 90, right? And so that's nice. That's a great start to this problem. But what does that give us? Well, think about it. This triangle right here is actually equilateral as a whole, this thing right here. So the answer, this side in total is going to be 12. And so this side would just be half of that. But let me back up a little bit. Why the heck is this thing equilateral? Well, this angle is 60. This angle is 60. And this angle is just 30 plus 30, which is also 60. Right? And so that's how I would know it's equilateral, right? All the angles are the same. So that means that this side is going to be 12. This side is going to be 12. And so AD, which is what the problem is asking for, and I'll write that in a different color so you can see it better. AD is going to be 6. It's half of that. That's choice B. All right. Awesome. Let's move on to problem 48. Okay. This is the last word problem for this video, I promise. All right. In State X, Mr. Camp's 8th grade class consisting of 26 students was surveyed, and 34.6% of the students reported they had at least 2 siblings. Okay, so I just want to start writing some stuff down because this is obviously, this is a long word problem. And so it's not just like they're giving you an entire bunch of information, an equation, and then giving you what it's actually asking for, and none of that above information matters. Like, you can see here that this is just a whole paragraph of information that we should probably take in, right? And, sometimes that's not always true. You'll get the feel for the question as you're reading it, but it seems like all this stuff is going to be key information. We should jot it down. Okay, class size is 26. 34.6% of these students say that they have greater than or equal to 2 siblings. Okay, and so it says the average 8th grade class size in the state is 26. Okay, so it matches Mr. Camp's class size. If the students in Mr. Camp's class are representative of students in the state's 8th grade classes, and there are 1,800 8th grade classes in the state, okay, so 1,800 classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? All right, so for this one, right, we are looking for fewer than 2 siblings. Okay, we're not looking for the number of students overall that have greater than 2 siblings, right? So let's make a note of that. We're looking for less than 2 siblings. And we're not just looking for less than 2 siblings in just his class, in Mr. Camp's class. We're looking for less than 2 siblings in all classes in the state. So what we can do is find the entire class size, right? The class size of the entire state, right? Or, well, the size of the 8th grade class, like the 8th grade, the grade right, across the state. So I'm saying class as the kind of like the all the people rather than classes in a classroom. So I just wanted to lessen the confusion, but I feel like I just created more. Class size is 26, 1,800 classes in the state. So how many kids are in 8th grade in that state? Well, that's 46,800. Put that in your calculator. Okay? Now that you have this, we know that 34.6% of them have greater than or equal to 2 siblings. Or they have at least 2 siblings. So how many have less than 2 siblings? Well, that's going to be 100 minus 34.6% of them, right? And, well, if you do 100 minus 34.6 in your calculator, you get 65.4. And you could maybe do that in your head if you want to. Okay? So 65.4% of this 46,800 has less than 2 siblings. So let's actually just multiply that together and see what that ends up being. Right? Remember, this is a percent. You're not just multiplying 46,800 by 65.4. You need to convert that to a decimal. And so we actually put in our calculators 46,800 times 0.654. And in doing that, we are going to get 30,607.2. Okay? Now notice like this number is kind of gross looking, and so what they do in this question is they just say estimate it, right? And so here you can see, which this is a gray section. So our answer is going to be 30,600, right? That's the closest to our answer. Moving on to problem 49. this problem says on the segment PS above, PQ is equal to RS. What is the length of PS? Okay, so we're looking for the length of this entire guy. Okay? And so to find that, we need to figure out what the heck x is, right? So how do we do that? Well, it gives us that PQ is equal to RS. So lengthwise, right, that means x minus 1 would equal 3x minus 7, right? This length equals this length. So now it just becomes a case of solving for x, and we can do that by subtracting for x here. And we could also add 7 on both sides, right? Getting all the x's to this side and all the other numbers, the constants, to the other side. When we do that, we get 6 is equal to, right, because this goes away, is equal to 2x. And dividing by 2, we get that x is equal to 3. Awesome. So now we know what x is, and so we can find this entire segment. We know that that segment, the length of that entire thing, is going to be x minus 1 plus x plus 3x minus 7. And when we add all of those up, we get 5x, right? X plus 3x. And we get minus 1 minus 7, and that's the minus 8. So plug in 3 for x. And we get 15 minus 8, and that is 7. And right there is the answer to question 49. Okay? So, pretty straightforward problem. Just got to realize, I think the hardest part of this problem is realizing to set x minus 1 equal to 3x minus 7. If you understand how to do that, this problem is pretty quick and easy. Problem 50. Our last problem of this video. I can finally be done with this, and you can finally be done with this, more importantly, right? Not enough about me, right? So, this problem says, the equation above models the number of members M of a gym T years after the gym opens. Of the following, which equation models the number of members of the gym Q quarter years after the gym opens? Okay, so you got to be careful when dealing with exponential functions, okay? Because a lot of you are probably going to think about the equation A equals A naught plus 1 plus R over N times NT, right? Like a lot of you guys are, sorry, I said that wrong, to the NT power, right? A lot of you are probably going to think about this thing, right? And then do that rate, right? The 1 plus 0.02 over, now you're talking about quarters, so you're going to divide it by 4, right? And that is a very common mistake on a problem like this, okay? But that's not what you're going to do here. Why? Why would this not be like a compound interest kind of thing, right? Like with quarterly compounding, because that's not what this problem is saying. This problem is just asking for the number of members in the gym Q quarter years after the gym opens. It's not saying that this is being compounded quarterly, right? If it's being compounded quarterly, that's a different thing. Then we're talking about compound interest. That's a different topic entirely, right? And now we're doing compounding every quarter. But this problem is just saying, hey, instead of giving me this, instead of me inputting years, can I just input quarters and then you can give me something? That's all it's saying. So it's saying convert years to quarters. Okay, it's not asking for quarterly compounding or anything like that. So all we have to do for this problem is figure out what T is in terms of quarters. Okay? And, well, there is 4 quarters in a year, right? And so if we have 4 quarters, right, we should be getting 1 year. And so we actually have to multiply our years by 4 for these two things to be the same, right? How do I know that? Well, again, just plug in 1 year, right? 1 year is equal to 4 quarters, right? That's t is in years. And then you get 4 is equal to 4, right? So that makes this equation true. Okay, so that's why we have to multiply our years by 4 and not our quarters by 4. Okay, anywho, here we need to solve for t, right? Because t is the exponent, and our exponent here is q over 4, 4q, right? It's all in terms of q, and so we're going to divide each side by 4 here and get that t is going to equal q over 4. And if we plug that into this equation, we know that this answer is going to be A, right? Since we're not doing any quarterly compounding or anything like that, the answer is not going to be C. Okay? That would be for where we are doing quarterly compounding. Okay? But again, this is something different. This is just saying, let's convert years to quarters. All right? And that is going to do it for this entire SAT math review. So I hope this video was able to help you, and definitely subscribe to this channel because I'm going to be doing a lot more SAT content on this channel. I have a SAT series on YouTube in the works right now. I'm going to be making videos on each topic specifically, so you don't have to like wait, for me to do an entire like 50 problem video like this and then only see the problems you really want to focus on once or twice in the entire 3-hour long video, or however long this video ended up being. So definitely subscribe so you can see those videos, and I'll also have that full SAT course linked in the description down below, so that if you want to go over those individual topics and you want to go over a ton of practice problems with me, I'll have that for you on the course. And yeah, I hope this video was able to help you. I hope you now feel better going into the SAT. And yeah, that's going to do it for me. So I'll see you soon.